Okay, we're recording. Let's go. Okay. Where was I? Okay, arithmetic. And yep, in this section. So yesterday I finished the multiplication part. Yeah. Now we're in intro to division. The idea of division. Let's go.
We've got 24.
Wait, what?
We've got 24 triangle things right over here. And what I want to do in this video is to divide it into different numbers of groups.
Okay, recording.
So the first thing I want to do is I want to divide this 24 triangle things.
Oh, I have two notifications.
I want to divide it into 3 groups and think about how many do I end up per group.
Okay.
So let's try that out. So I'm going to divide it into 3 equal groups. So that is one equal group right over there. Then I have another equal group right over here.
3 groups
and then I have a third equal group right over here. So if I divide 24 into 3 equal groups, 1, 2, 3, how many are going to be in each group? Well, we can count that. We have 1, 2, 3, 4, 5, 6, 7, 8 in each group.
That
so we can say that
man.
24 divided by 3 is equal to 8. Now you might say, hey, this is very similar to what we saw in multiplication. In multiplication, we said if we have 3 groups of 8, we could view that as 3 times 8 and get 24. And you are exactly right. We could also write 3, let me do those same colors. We could also write that 3 times 8. So if I have 3 groups of 8, that is going to be equal to 24. So we started in this video. We had 24 things. We want to divide it into 3 equal groups. We got 8 in each group. Or you could say 3 equal groups of 8 is equal to 24. But there's even other ways of thinking about this. So let me clear this up a little bit. So let me clear that. We could also view, so in the first example, I divided 24 into 3 equal groups. But you could also view 24 divided by 3 as dividing 24 into groups of 3. So let's think about what that looks like. So if we divide it into groups of 3, then for example, this is a group of 3.
Oh, wow, okay.
That is a group of 3. This is a group of 3. You might see where this is going. That's a group of 3. That is another group of 3. And we're going to think about how many groups of 3 we're actually going to get. So this is another group of 3. And that's another group of 3. So how many groups of 3 did we get?
I got 8 groups of 3. I think this is
3, 4, 5, 6,
looking at
7,
this
8 groups of 3. So another way of viewing 24 divided by 3 is divide 24 into groups of 3, and then you will have 8 groups of 3. And one way of thinking about this, if you want to express the same thing in terms of multiplication, is if you have 8 groups of 3. If you have 8 groups of 3, that is also going to be equal to 24. Whether you have whether you have 3 groups of 8 or 8 groups of 3, either way, you're going to have 24. Now, let's make things more interesting. What I want you to think about is based on what we just saw, what is 24? What is 24 divided by 12? And I encourage you to pause the video, draw out 24 triangles like this, and try to figure out what 24 divided by 12 is.
I don't want to draw 12 triangles.
Well, I assume you've paused the video, and there's 2 ways to think about 24 divided by 12.
But
you could say, well, let's divide 24 into groups of 12 and think about how many groups we have. So we could do that. So let's see. This is one group of 12 right over here. That's one group of 12, and then here is another group of 12. It's another group of 12. So how many groups of 12 do we have?
You have 2 groups.
Well, we have 2 groups of 12. So we could say 24 divided by 12 is 2. But another just as reasonable way of doing this is you could have said You could have said, well, let me divide 24 into 12 groups instead of groups of 12. So if I want to divide it into 12 groups, 12 equal groups, well, let's see. This is one equal group, two equal groups. Actually, let me do it this way. Well, let me do this here. Two equal groups,
Well,
three.
how would you know it was 2 in the
four,
first place, right?
5, 6, 7, 8, 9, 10,
How did you know all to get
11, 12.
each?
So once again, if you say, well, I'm going to divide 24 into 12
didn't do the
equal groups,
first
how many
way.
do you have in each group? Well, you have 2. So once again, 24 could be viewed as 24 divided into 12 equal groups, and how many you have in each group, or 24 divided into groups of 12, and how many groups would you have? And that's what we saw in the last example. So now let's make things even more interesting. What I want you to think about, a couple of things. I want you to think about what 24 divided by, let's say,
like
divided by 6 is. And I also want you to figure out what 24 divided by, let me use the same color,
4
divided by 4 is. Divided by 4 is. And once again, I encourage you to pause the video, draw out these triangles, and figure it out. What is 24 divided by 6 and 24 divided by 4?
4 and then 6.
So let's tackle 24 divided by 6 first. And I'll view this as, let's try to divide 24 into 6 equal groups. 6 equal groups. So let's see, this could be one equal group, two equal groups. In fact, each group here is a group of 4, and we have 6 rows. So 3 equal groups, 4, 5, and 6. And so if you divide 24 into 6 equal groups, how many do you have in each group? Well, it's pretty clear. You have 4. You have 4 in each group. Another way we could have thought about that, is we could have said, let me divide 24 into groups of 6. So if you divided 24 into groups of 6, you could have viewed it like this. So that's one group of 6. That's one group of 6 right there. That's another group of 6 right over here. It's another group of 6, and I think you see how many groups of 6 we have. How many groups of 6 we have? We have 4.
I prefer.
We have 4 groups of 6. 4 groups of 6. Well, now let's think about what 24 divided by 4 is. Well, if I view 24 divided by 4 as taking 24 and dividing it into 4 equal groups, I've just drawn that. I have 4 equal groups, and in each group I have 6. In each group I have 6. So notice, 24 divided by 6 is 4. 24 divided by 4 is 6. And that's because I could view this as 4 groups of 6, or say that 4 times 6 is equal to 24. Or you could just as equivalently say that 6 times 4 is 24. You could equivalently say that 6 times 4 is equal to 24. We have 3 different pictures here, and my question to get us warmed up is which of these could represent 20 divided by 4? Pause this video and see if you can figure
Yeah, it's the
that
third one. This one's 25, this one's 16.
So let's go through each of these. And actually, let's think about
It's
what
20
each of them
divided
could
by
represent.
4, so you get 5 of
So
each.
how many total circles do we have in this picture right over here?
16.
Let's see, we have 1, 2, 3,
That's 4 times 4.
4. And then we have 4 groups of 4. So 4, 8, 12, 16. So this looks like 16 circles. 16 circles divided into, we could view it as divided into groups of 4. Or we could actually also view it as divided into 4 equal groups, because both of those are true, and we see that that is going to be equal to 4. So this one over here, it's really representing 16 divided by 4, not 20 divided by 4. Now what about this one? Well, let's see. Here it looks like we have 1, 2, 3, 4, 5 groups of 1, 2, 3, 4, 5. So this looks like 25 circles divided into groups of 5. Or divided into 5 equal groups, which is, of course, equal to 5. So this is 25 divided by 5, not 20 divided by 4. Now, but what about this one? So let's see. We have 1, 2, 3, 4, 5. And we have 1, 2, 3, 4 groups of 5. So 5, 10, 15, 20. So we definitely have 20 circles there. And we have divided it into 4 equal groups. We have divided it into 4 equal groups. And so that's exactly what we're talking about, or what we started talking about. This is 20 divided by 4. And you can see when you take 20 and divide it into 4 equal groups, then you get 1, 2, 3, 4, 5 circles per group. And we're done.
Cool. Division and context.
We are asked which problem
Am I recording though? Okay, I am recording.
can we solve with 42 divided by 7? And they explain 3 different scenarios here. We need to pick one of them. So pause this video and have a go at it before we work through it together.
Okay. Gonna give it a go. Steven packed 42 candy bars in his bag. He gave 7 of them. No, that's subtraction. There are 42 jelly beans in one bag. How many jelly beans does Julie have? I think this is 42 times 7. Leslie ran for 42 minutes total in 1 week. If you run the same number of minutes each day, how many minutes does Leslie run in 1 day? Okay. Yeah, it's the third one.
All right, now let's work through this together. So let's see. Choice A says Stephen packed 42 candy bars
How many minutes
in his bag.
in 1 day?
He gave
For
7
1 week,
of
7,
them
and
away
76
to his
minutes in 1 day.
friends. How many candy bars does Stephen have left? Well, this isn't a situation of dividing. This is a situation where he starts with
Subtracting,
42
yeah.
and he takes 7 of them away. So this would be the expression 42 minus 7, not the expression 42 divided by 7. Rule that one out. Julie has 7 bags of jelly beans. There are 42 jelly beans in one bag. How many jelly beans does Julie have? Well, for each of those 7 bags, she has 42 jelly beans. So this would be 7 times 42, not 42 divided by 7. Rule that one out. Leslie ran for 42 minutes total in 1 week. If she ran the same number of minutes each day, how many minutes did Leslie run in 1 day? So she ran 42 minutes in total in the week, and she ran the same amount every day. There's 7 days in a week. So if we want to figure out how much did she run per day, you just divide the 42 minutes total divided by 7 days in a week. To figure out, this would tell you right over here, how many minutes Leslie ran each day. And so that is the problem that we would solve with 42 divided by 7. Let's do another example. Here we are told Caleb has 21 action figures. He puts 3 action figures in each box. What does the expression 21 divided by 3 represent? So pause this video again and see if you can answer that.
Caleb has 21 actions, put 3 actions in each box. Oh, okay, it's a number of boxes that.
All right, so this is a situation where we're starting with 21, and we are dividing it into groups of 3. So these are groups of
Wait,
3.
number of action figures in each box? Total number of action figures? What does explain? What's the number of boxes?
So this is going to tell us how many
you
groups
have
we
3
need
in
if we're
each
going to
box.
divide 21
Already.
into groups of 3. So
That's
if I wrote
definitely A.
21 divided
If I'm
by
wrong, I'm gonna kill myself.
3, and so this is groups of 3. Groups of 3. This is going to be equal to something, and many of you might know what this is, but this is going to tell us how many groups. How many groups. And here, a box represents a group. How many groups? And so this is going to be the number of boxes. The number of action figures in each box, they already told us there's 3 in each box, so that would be represented just by 3. And the total number of action figures, that would be 21. The number of boxes is the total number divided by how many in each box. Let's do another one.
7. You didn't give the answer,
Alex,
man.
Brian, and Marta split a box of 12 cookies evenly. Which expression helps us find out how many cookies each friend will receive? So pause this video again and see if you can tackle it.
No, it's
All
still
right, so
divided
we're
by 3,
splitting
man.
12 cookies. So we'll start with 12, and we need to divide it. And
By
how many
4.
people are we dividing it between? Well, we're
3
dividing it
people.
between 1, Alex, 2, Brian, and 3 people, Marta. So we're going to divide it into 3 equal groups. And you might know what that is, but we don't even have to figure that out. We just have to say, hey, how many cookies does each of the 3 people receive? Well, it's going to be 12 divided by 3 cookies. So it is this choice right over here.
Yeah, we're looking for the
3
expression,
divided by
not
12
the...
doesn't make sense in this situation. You don't have 3 cookies, and you're not dividing it amongst 12 people. And C doesn't make sense. You're not just taking 12 cookies and dividing it between 2 people. You're dividing it between 3 people.
Oh, okay. That ended abruptly, but okay. Which image could represent 36 divided by 6? Okay. What is this? A 4 groups of 6. Has 27 house. Divided evenly in 3 bags. Oh, okay. 7. Okay, it's gonna be this one. So we have, should be 7 and then 2 of them. Which currently represent the picture shown below? It's 24 divided by 3. Oh shit. Oh crap. I get it. It's 8. Wait, what? Choose 2 answers. Holy crap. I already messed up on the third question. What does the saving mean? I think it's about AB, right? That's so weird, man. There are 10 cookies divided into 10 groups of 2. Oh wait, there are 10 divided by 2 and... yeah, that's pretty much it. Which image should represent 20 divided by 4? Okay, it's 20 and in each group we have 4, so we get 5. Marlowe's 24 acorns, he put them into groups of 8. Which image can represent the situation? Into groups of 8. So we got 3 groups. We have 28, 1, 2, 3, 4, 5, 6, 7. It's divided by 7. And each... oh fuck, 2 answers. The 4. It's so weird, man. This thing represents 28 divided by 7. So we have 7 groups. And then we divided by 4 and then we get 7 groups. The same shit that I got wrong in the third question. Wait, what? Why did I get it correctly? The fuck? Okay. There are 10 jumping monkey. We want to divide them equal into 2 beds. Okay. 5 for each bed. How many rows are there? It's gonna be 6 rows. It's gonna be 9. 9 dots in each row. Oh, it's gonna be 4 rows. The pigs into equal groups so that each group has 7 pigs. So you got 4 groups. There are 24 pieces of cheese. We want to divide them equal to 6 bags. Okay. So, oh, okay. 4 pieces per bag. So we can find 72 divided by the splitting of 72 dots so that there are 8 dots in each row. Okay, it's gonna be 9. How many rows are there? Maybe 9 rows. Okay, it's gonna be 5, but in each row we get 5. Very cool. That's pretty cool. Next. Find the missing value. It's 3. No, we're not using any pictures now. The first one used pictures of I don't know, abstract. What am I saying? Just go. What's about it? No, it's 45 divided by 5, it's 9. 70 divided by 10. And whoa, that's 18 divided by 6. One digit division. It's gonna be so much harder with multiple, which currently represent the array shown below. Okay, got two answers. Maybe 4, 5, 6, 7, 8, 9. That's 18 divided by 2, definitely. Then we have 18 divided by 9, which will give us two groups. There are 5 equal rows of books. There are 25 rows. Which will tell us how many books are in each row. It can be 25 divided by 5. Which you make 12 divided by 6. So yeah, we have 12 divided by 6. Then each of the group we have 2 of them. Which expression could represent the array shown below. Choose two answers. So I guess this is 5 times 7. 5 by 7, and we got 7 groups. So we got 35 divided by 5 and 35 divided by 7. Could be wrong. Oh yeah, that's good. Because if you divide by 7, then you get 5 for each row. There are 20 total people split into 2 groups. Which expression tells us how many group people there are? Okay, so there are 20 divided by 2, you get 10 for each group. Oh shit! I just spilled my freaking water, man. Oh shit. I'm getting... Okay, good. So I changed my shirt. And yep. Also got myself another round of coffee. Yep, let's continue. There are 20 total people split into 2 groups, which tells us how many groups of people are there. How many groups of people? Oh, okay. Image could represent 30 divided by 9. It's gonna be 4. No. It's this. No. Wait, what? 36 divided by 9? Definitely, we got 4 groups. Oh yeah. I was thinking the other way around, where you would divide it by 9 groups, right? And then in each group you got 4. So this is like 36 divided by 4, and we get 9 for each group. I think it's quite confusing. This 36 divided by 4 is better. 36 divided by 9 is better represented with this guy's divided by into 9. Which expressions represent the array shown below? Okay, so 42 divided by 8. You're definitely gonna get nuts. Is this, wait, what? I mean 7 is 56 and 6 is, oh, it's because this one's wrong. It should be 48 divided by 6 and 48 divided by 8. Yep. Yeah, because you got 48, all of them divided into 6 guys. And then at the same time we have 8 for each row, and then yeah, I hate it. Okay. There are 48 people in the cafeteria, divided evenly between 8 tables. What does their expression? There are 48 in the divided evenly by. Oh, okay, so that's the table for each person. Amy has 16 video games. She puts them into stacks of 4 games each. Which expression help us find how many stacks of games there are. And 16 divided by 4. Which problem can we solve 63 divided by 9? Tatsu needs 9 lemons to make a pitcher of lemonade. If Tatsu had 60 lemons, how many can he make? How many lemonades? No, it's gonna be pitchers of lemonade. Okay, that's correct. So we went one answer on, but we're gonna check the other ones as well anyway. So Jessica has 63 pieces of pizza left. She ate 9 pizza with her friends. No, it's subtraction. No, you add. There are 56 rooms in a hotel room, evenly 27 floors. It's the number of rooms per floor, right? Thomas 30 books divided even into 6 boxes. Which is we still have to find how many books. So it's gonna be 30 divided by 6. Which problem can we solve 30 divided by 4? Okay. Another museum has 4 rooms. The museum has 30 points, puts the same number of paint. Okay, it's the first one. Fred has 30 rows of carrots. There are 4 carrots in each row. How many carrots does Fred have in all? No, that's 30 by 4. A chef needed to put 30 plates away in the kitchen. She broke 4. Adam's 12 ice cubes. He divides them equally 2 cups. So you get cubes per cup in each cup. Alright, division, place, value, and area. Let's see.
Let's say you want to figure out what 5,600 divided by 8 is. Now you might be tempted to do some type of long division, 8 into 5,600, and you could do it this way and using paper. But what I want to show you is that you could maybe do this in your head, or maybe even just use. Let's say you want to figure out what 5,600 divided by 8 is. Now you might be tempted to do some type of long division, 8 into 5,600, and you could do it this way and using paper. But what I want to show you is that you could maybe do this in your head, or maybe even just use less paper to do it. And the key realization here is like, look, if you got these 2 zeros here, this is really the same thing as
56
56
divided by 8 times 100.
Times 100 divided by 8. 56 times 100 is 5,600. You got the 2 zeros here, you got the 2 zeros here. Let me make it very clear. 2 zeros here, you got the 2 zeros here. In fact, sometimes people will call this number 5,600, 5,600s. So 5,600 is the same thing as 56 times 100. And when you write it this way, then you might say, hey, well, instead of doing 56 times 100 divided by 8, I can switch the order. This is going to be the same thing. This is going to be the same thing as 56 divided by 8 times 100.
Wait, what if I do 100 divided by 8 times 56?
100.
Holy shit, bro.
Times 100. Now, why did I do this? Well, it's pretty straightforward if you remember your multiplication tables what 56 divided by 8 is. 8 times 7 is 56. So this right over here is going to be 7. And so then you're just left with figuring out what 7 times 100 is. 7 times 100. Well, that's going to be 7 hundreds, or 7 hundreds is just 700. 700.
And you're done.
You're done. Let's do more of these where we might be tempted to do some type of long division, but if we really think about ways to break up the numbers, we might be able to do it with less paper or possibly even in our heads. So let's say that you had the number, 800, using a different color. Let's say you had the number 846. 846. And you want to divide that by 2. Well, the realization here, or what you might think about, is let's break this number up. Let's break up this 846. 846
423.
is the same thing. This is going to be, actually, let me do it this way. 846 is the same thing as
800
this is the same
divided
thing
by
as
2
800
plus 40 divided by 2 plus 6 divided by 2.
plus 40 plus 40 plus 6 plus 6. And so 846 is the same thing as 800 plus 40 plus 6. And so we can just divide that by 2. We can just divide that by 2. Divided by 2. So notice, didn't do anything too fancy here. This is just the same thing as this over here. And I just broke it up. You have 800s, 4 tens, which is 40, and 6. And you can divide that by 2. Well, how does that help us? Well, now we can divide each of these separately by 2. One way to think about it is we can distribute the division by 2. Where you might be familiar with using the distributive property on multiplication, but you could also do it with division.
You haven't
so
even.
This thing right over here is going to be the same thing. This is going to be equal to 800 divided by 2. 800 divided by 2 plus 40 divided by 2 plus 40 divided
You
by
didn't
2.
tell me anything about
I'm gonna add
distributive
parentheses in a second to make it a little bit clearer.
property stuff.
Plus
I
6
mean,
divided
we've been doing it, but there was no property deduction
plus
for that.
6 divided by 2. Plus 6 divided by 2. Divided plus 6 divided by 2. So once again, you have 800 divided. We do that same. You have 800 divided by 2. That's that right over there. Plus 40 divided by 2. 40 divided by 2. Plus 6 divided by 2. Plus 6 divided by 2. So we distributed the division by 2. Well, 800 divided by 2, you should do in your head. This is 800s. Divide that by 2, you're going to get 400s. 400. 4 tens divided by 2 is going to be 2 tens.
The parenthesis thing. The parenthesis thing.
2 tens or 20s. So
He's not explaining
800s divided
why.
by 2 is 400s. 4 tens divided by 2 is 2
The
tens.
parenthesis. I mean,
6 divided by 2 is
if I did 800 divided by 20 plus 40, that would be 440, and it would be divided by 2, then it's going to be a different thing.
3. So you
So
are left with
he did that, but he did not explain
400
like why it should
plus
be.
20 plus 3,
kind of weird.
which of course is equal to 400.
Even though
and
I know that's gonna be,
423. Now I use
but just kind of
a
taken
lot
for
of my
granted.
screen here to work this out for you, so that you really digest what's going on here. But once you get good at it, you can say, okay, look, 8 divided by 2 is 800s divided by 2 is 400s. Actually, I could do it right over here. 800s divided by 2 is 400s. 4 tens divided by 2 is 2
2
tens.
tens
And 6
3
ones divided by 2 is 3 ones. So you could say, hey, look, if I just divide each of these numbers by 2, I get 423. But this is what you were really doing. You were separating it out by place value. You were dividing each of those places, the hundreds, the tens, and the ones by 2, and then you got 423. And by the way, that's exactly what you would do if you actually did it through long division. You're actually just dividing the 2 into each of the places. Let's do one more, just to really make sure that we are fully enjoying
this.
So let's say that I have 963, and I want to divide that by 9. Well, over here, you might make the realization, well, I can see parts of this that I know how to divide by 9. So I could say this is the same thing as 900, and I'm breaking out the 900 because I know how to divide 900 divided by 9. So that's 900. And then I know that 63 is a multiple of 9. So why don't I break out 63 separately? I don't even have to break out the tens and the ones separately. So I could say this is the same thing as 900 plus 63, and all of that divided by 9. Well, this is going to be the same thing as 900 divided by 9. We do that in the brown color. 900 divided by 9
107
plus 63 divided by 9 plus 63 divided by 9. I just distributed the division by 9. Let me put some parentheses around this. And what is this going to be equal to? Well, 900 divided by 9 is 100. This is going to be 100. And 63 divided by 9 is 7. So this is going to be 100 plus 7, or 100, 100, and 107. And so once again, I wrote it all out like this, but once you get some practice, you'll say, hey, look, 9 goes into 900 100 times. 9 goes into 63 7 times. So 9 goes into 963 107 times. Hopefully you found that fun. And this is useful stuff, because one of the most important things you're going to have to find is all the time you're going to find these numbers while you're doing, your finances, or you're trying to calculate the check at a restaurant, and you're going to find it really valuable to be able to do this type of division, and with some practice, even without paper.
Cool.
Let's say that this rectangle, this green rectangle right over here, let's say it had an area of 268 square units, whatever those units are. You could imagine them being square centimeters, or if you imagine this being a big field that you're looking at from space, it could be square miles or something. So I'm just going to write square units. And let's say you knew the dimensions of one side of the field. So let's say that you knew that this, let me do some color, let's say you knew that this side of the field right over here, the length of this side of the field is 2 units. 2 units. And I haven't really drawn this to scale. If I wanted to draw it to scale, it would be like much shorter. It would be like that, but you would have trouble seeing the rectangle then. But let's just assume it's 2 units. So if you know the whole area is 268 square units, and one side is 2 units, what's the other side going to be? What is the other side going to be? What is, let me pick another color. What is this side? What is this side of this rectangle, this field, whatever this might be? What is the length of that side? Well, if you multiply these two sides, you get the area. So if you start with the area, if you start with 268, and you divide by the other side, divide by the other side, you're going to get the length of this side right over here. So if we wanted to figure out the length of that side, it would be 268 divided by 2. And you've already seen, or we've already seen, multiple ways to figure out what 268 divided by 2 is. But the whole reason of me drawing this rectangle, or this aerial view of this field, or whatever you want to call it, is so that we visualize it using area. And so one way to do it is to break up this 268 square unit area into areas that are easier to imagine dividing by 2. So here I have the same field, but I've just broken it up. So it's the same field. This dimension right over here is still 2 units. 2 units. But I've broken it up. This blue area is 200. Let me do that in another color. So this blue area is 200 units. This yellow area is 60 units. And this magenta area is 8 units. Now, why is that useful? Well, now each of these, it's much easier to divide by 2. All I did is I took the 268 and I said, well, look, this is the same thing as 200 plus 60 plus 60 plus 8. I just broke up the 268 into things that are easier to divide by 2. And now I can take those things and divide by 2. I can take each of them and divide by 2. So what is this dimension going to be right over here? Actually, let me do that.
100.
What is this dimension
Let's go.
right over here going to be? Well, 2 times that is going to be 100. So this is going to be 100. And how did we get that? Well, we got that by 200 divided by 2. 200 divided by 2 is 100. What's 60 divided by 2? Well, 60 divided by 2 is going to be 30. So this part of the field is going to be 30 in that direction and 2 in this direction. And once again, not drawn to scale. And then finally, what's this section going to be? It's going to be
4.
8 divided by 2, which is 4.
You almost
100
wrote
times
8.
2 is 200. 30 times 2 is 60. 4 times 2 is 8. And so this whole length up here is going to be 100 plus 30 plus 4, or 134. And we've already seen other ways of coming up with this. You can say, look, 2 hundreds divided by 2 is 100. 6 tens divided by 2 is 3 tens. 8 ones divided by 2 is 4 ones. And that's exactly what we just did over here, but we visualized it using this kind of a rectangle, breaking it up into chunks that are maybe easier to imagine dividing by 2. We broke it up into 2 hundreds right over here. We broke it up into 6 tens, or 60, right over here. And we broke it up into 8 ones. 8 ones. We broke up the area, and then we took each of those areas and we divided it by 2 to find that part of the length. And when you add them all together, you get the entire length. Now, that's just one way to do it, where you take each of the place values and you break up your field or your rectangle like that. But you could do it other ways. You don't always have to break.
Shit, someone's snapping. Okay, I'm back.
To break it up that much. For example, let's say that this area is 856 square units. And let's say that this dimension right over here is 8 units. So how could we break this up so it's easier to think about what the other dimension would be, what the length is going to be? And this length, once again, is going to be 856
or just 8
divided
by
by
56
8.
because the 6th one. Yeah.
856
So 800 and then
divided
56.
by 8
So
is
that's
this
going to be
length right over here.
107.
Well, you could break it up into 800s, 5 tens, and 6 ones, but you might notice, well, 5 tens, it's not so easy to divide that by 8. But we can divide 56 by 8. We know that 8 times 7 is 56. So what you could do is you could break this rectangle into the 856 square units. You could break it up into 800 square units, and then another 56, and another 56 square units. So once again, we broke it up into 800s, and then 56 ones, and then 856 ones. Same area, I just broke it up. And now if you say, look, this is 8. If you say this right over here is 8, well, what is going to be this length? What is this length up here going to be? Well, it's going to be 800 divided by 8. So actually, let me write it below it. So 800 divided by 8, this length right over here is going to be 100. How did I get that? I got 800s divided by 8 is 100. 800 divided by 8 is 100. And then you have this other magenta part. What is 56 divided by 8? Well, that's 7. 56 divided by 8, this length right over here is going to be 7. So what's this entire length? Well, it's going to be 100 plus 7, which is equal to 107. So once again, you could have said, look, 8 goes into 800 100 times, 8 goes into 56 7 times, 107. Why did Sal draw these rectangles? Well, just so that you can help. It's sometimes helpful to visualize this. Is, hey, look, this is an area problem. If this is the total area of 800.
But does my record also captures the audio?
56 is the total area,
okay.
And 8 is one of the
5 seconds.
If this is the total area, if 856 is the total area, and 8 is one of the dimensions, well, then 856 divided by 8 is going to be the other dimension. And one way, when you're breaking this up by place value, you're breaking up the numbers into pieces that are easier to divide by 8, you could think of it as you're just breaking up that area, and you're just trying to figure out parts of this length. So that's 100 right over there, and then this right over here is 7. So anyway, hopefully this brought it that area into the picture. And one way, when you're breaking this up by place value, you're breaking up the numbers into pieces that are easier to divide by 8, you could think of it as you're just breaking up that area, and you're just trying to figure out parts of this length. So that's 100 right over there, and then this right over here is 7. So anyway, hopefully this broadens your visualization capabilities when you are dividing multiple when you're doing division.
Alright, cool. Get 3 out of 4 to level up. Nora tried to evaluate an expression step by step. Find Nora's mistake. Okay. 1500 divided. Nora did not make a mistake. She's really good. Complete the equation, solve. No, the one. This is the problem with my shitty keyboard. The uh, the cap, the one. Sometimes like it's very soft to the touch, and it just double sometimes, even if you press slightly. Kevin tried to evaluate an expression step by step. Find Kevin's mistake. Okay, seems right. 300, okay. 5, 300. Kevin did not make a mistake, it's also good. So 4, 5, 6, 3. That's gonna be it's divided by 9. It's divided by 9 as well. So that's 40. It's 500. That's 7. Oh man, got one wrong because of my shitty keyboard. Oh, alright, that's cool. Got something new. Okay. Okay. So I guess it's gonna be 100. And then, am I supposed to divide each by 4? I am, right? Into parts that are easy to divide by 4 and a remainder. Oh, the remainder is 1. It's 769, okay. So 360, it's gonna be 90. Then we have 2. And H is gonna be the total, right? So 192. 192 remainder 1. Is 1 supposed to be the remainder? I don't know. Let's see. Okay, cool. Gather split there to help her solve the division equation 787 divided by 7. She splits the rectangle to parts that are easy to divide by 7. Okay. So it's gonna be 1000 and 100, and it's gonna be 40. 40, right? Yeah. And then it's gonna be D. Whoa, it's gonna be 1. Then H is gonna be the total. Okay. Total. It's gonna be 1141. Okay, there's no remainder, so I guess this will do. Irina split up the area of rectangles. Help her solve the equation 420 divided by 2. She splits the rectangle into parts that are easy to divide by 2. Let's split. Oh shit. B is gonna be 10. Yep, and then H is gonna be the total, 210. So it's maybe 10. Yeah. Okay, same thing. Yep. Okay, so 5000 divided by 5 units. I don't even know. I think it's gonna be oh shit. I don't know. It's gonna be 1000, right? Yeah. Wow, I'm an idiot. 30 60. Yeah, 60. Because 5 times 6 is 300. That's 5,000. And for the C1, oh shit, it's gonna be 10, right? The D1, we got 2 of those. Okay. So total is gonna be 1072. Please be correct. Thank you. Wow, I'm having brain farts or something. Why does it say try again? What the heck? Why is it say try again? Okay, let's try again. Ryan tried to evaluate an experiment step by step. Find Ryan's mistake. Okay, 2000 is correct. That's correct as well. 950. Yeah. It's 400, and that's gonna be 60. Okay, yeah. 461. Holy crap. Step 3 is wrong. Okay, so 4008, we have 500. 560. Wait. No, it's 560. And then, so we're gonna have 500, 571. Hopefully this is correct. No, I know this is correct. Nate tried to evaluate an expression step by step. Find Nate's mistake. Okay. Oh, wait, so this is correct. And this is correct as well. So, 64, 8, yeah, 800, 32, yeah, that's correct. Okay, Nate did not do any mistake. Did not make it. Nate's pretty good. Oh shit. No way. I'm the one who made a mistake. Kigrasam. No, it's dance game. This is obviously correct. Oh my god, why is that a minus sign? It's a minus sign, what the heck? This is sneaky. God damn it. Mel tried to evaluate an expression step by step. Okay, 60,060 divided by 3. I think he made already this mistake very first step. Complete the equation to solve 970 divided by 9. So we have 900 divided by 9 and 70 divided by 9. And 70 divided by 9 is going to be 8. So we have 108. Okay, so Fiona tried to evaluate an expression. Find Fiona's mistake. Okay. 840 and 6 divided by 7. Alright, step 2 is definitely wrong. Alright, complete the equation to solve 707 divided by 7. So that's correct. Yeah, it's gonna be 1000 plus 1. Yeah, 1000. Okay, cool. Multi-digit division, no remainders.
In this video, I'll introduce you to a new way of computing division, especially for larger numbers, and then we'll think a little bit about
long
why
division.
it works. So we're going to try to compute what 96 divided by 4 is. I'm going to write it a little bit differently. I'm going to write 96 divided by, so I'm going to write this kind of strange looking symbol right over here, this thing that kind of covers the 96. But you could view this as 96 divided by 4. And I'll show you in a second why we write it this way. This is actually a very useful way of actually computing it. So the first thing we'll do is we'll say, well, how many times does 4 go into 9? Well, we know that 4 times 2 is equal to 8, and that 4 times 3 is equal to 12. So 3 would be too much. We'd go above 9. So we want to be below 9, but not have too much left over. If we could, we want the largest number that gets us into 9 without
going over 9.
So we'll say it goes 2 times. 4 goes into 9 2 times. And then we say, what's 2 times 4? Well, 2 times 4 is 8.
It's going to be 8.
2 times 4 times 2 is 8, or 2 times 4 is 8. And now we subtract. We subtract the 8 from the 9, and we get 1. We get 1. And now we bring down the next digit, which is the 6.
We subtract 8.
And then we ask ourselves, well, how many times does 4 go into 16? Well, in this case, we know that 4
Wait,
goes
what did you say?
ourselves. Well, how many? And now we bring down the next digit, which is the 6. And then we ask ourselves, well, how many times does 4 go into 16? Well, in this case, we know that 4 goes into 16 exactly 4 times. 4 times 4 is 16. So we say 4 goes into 16 4 times. Then we multiply 4 times 4 is 16. We subtract, and 16 minus 16, we have absolutely nothing left over. And there we have our answer. I know it seems kind of magical at this point, but in a few seconds we're going to think about why this actually worked. We got that 96 divided by 4 is equal to
24.
different color.
That is so good.
Equal to 20 is equal to 24. Now what I want you to do right now is pause this video and think about, why did this actually work? How did we magically get the right answer here? And you can verify this. Multiply 4 times 24 and you will get 96. Well, I'm assuming you gave a go at it. And the important thing, as always, is to keep track of the place value. And it really tells you what's going on when we do this process. When we looked at this 9 right over here, this 9 is in the tens place. This is actually representing 90. It represents 9 tens. So we're saying, well, how many times does 4 go into 90 without going... how many times does...
Okay, someone's knocking again. Okay, I'm back. My hair sucks. I need a haircut. God damn it. Let's go.
This is 4
Long division
into 90 if we're thinking about multiples of 10. Well, it goes 20 times. 4 times 20 is 80. And so we said, well, 4 times 20 is 80, but we still have 16 left over. You do 96 minus 80, you have 16 left over to divide 4 into. And then 4 goes into 16 4 times. So really a lot of this is just saying, well, we first figured out that we could go 20 times, and then we said, well, that doesn't get us all the way to 96. We have to go another 4 times. Hopefully that helps.
Wanna
9 right over here. This
you watch
9 is in the
the
tens place. This
explanation
is
of the
actually
last part.
representing 90. It represents 9 tens. So we're saying, well, how many times does 4 go into 90 without going... how many times does 4 go into 90 if we're thinking about multiples of 10? Well, it goes 20 times. 4 times 20 is 80. And so we said, well, 4 times 20 is 80, but we still have 16 left over. You do 96 minus 80, you have 16 left over to divide 4 into. And then 4 goes into 16 4 times. So really a lot of this is just saying, well, we first figured out that we could go 20 times, and then we said, well, that doesn't get us all the way to 96. We have to go another 4 times. Hopefully that helps.
Thus.
Let's tackle a slightly more interesting division problem. So we're going to take 280 and divide it by 5. And I encourage you to pause this video and try to apply the technique that we've seen in the previous video to try to figure out what 280 divided by 5 is. So let's have our go at it.
The
So
5
we
can
rewrite
go,
this. We've
so
already seen
it's going to be
this.
0, and then it'll break down to
divided by
28 divided by 5.
by
Right?
5.
Okay,
So the first question
5
we can
is
ask
gonna lift
ourselves
up
is, how
over
many times
30.
does 5 go into 2?
I think I can solve this mentally. Let's try. So 5. Oh shit, I can't. 5 and then left 3 over 30 divided by 5. It's 76. That's 56.
Well, 5 doesn't go into 2 at all. It goes 0 times. 0 times 5 is 0, and then we subtract. 2 minus 0 is 2, and now we can bring down the next digit, which in this case is an 8. And so we can ask ourselves, how many times does 5 go into 28
That's gonna be
without
5
going
times.
over it? So we could think, well, let's see, 5 times 5 is 25.
And 5 times
5
6 30.
times 6 is 30. So 5 times 6 would go over to 28, so we would want to go back to 5 times 5. So 5 goes into 28 5 times. 5 times 5 is 25.
Then
And
subtract
we
again.
Subtract. 28 minus
30.
25 is 3. And now let's bring down the next digit. In this case, the digit is a 0. So how many times does 5 go into 30? Well, it goes exactly 6 times. We've already talked about that. 6 times 5 is 30.
So good.
We subtract. We have nothing left over. So we just figured out that 280 divided by 5 is equal to 56. Now, why did this work? Well, the first way to think about it, this was actually 200. And we were thinking about, do we put anything in the hundreds place here? So one way of thinking about it, how many hundreds of times does 5 go into 200? And it doesn't go any multiples of 100. And if that's a little confusing, don't worry too much about it. But I want you to really think deeply about the place notation. But then we were able to again extend it to, instead of just 200, but then 280. This 28 right over here, if you think about it, this 2 is in the hundreds place. This 8 is in the tens place. So this is really representing 280. And we said, how many tens of times does 5 go into 280? Well, it goes 5 tens times, or it goes 50 times. 50 times 5 is 250. When you subtract 250 from 280, you got 30. And there was no other things in the ones place here, so we just had to figure out how many times does 5 go into 30. So hopefully that gives you a sense of what's actually happening behind this little process, it's not just magic. We're really just keeping track of place value here. The other thing I want to show you is that we didn't necessarily have to write this 0 here. Another way of computing it, we could have said 280 divided by 5. We could have said, how many times does 5 go into 2? Well, it doesn't go any times. So let's just think about 5 go into 28, 5 going into 28. Well, 5 goes into 28 5 times. 5 times 5 is 25. Subtract. 28 minus 25 is 3. Bring down the 0. 5 goes into 30 6 times. 6 times 5 is 30. And we have nothing left over. And again, what we were really saying is that 5 doesn't go into 200 any hundreds of times. If this was a 500, you could say, hey, it's going to go in at 100 times. But instead we go, well, what about 5 going into 280? Well, it goes 50 times. 50 times 5 is 250. 280 minus 250 is 30. 5 goes into 30 6 times. So hopefully that makes a little bit of sense.
It does. Holy shit.
What we're going to do in this video is start trying to divide by 2-digit numbers. And as we'll see, this is a super important skill that a lot of the rest of mathematics will build off of. But it's also interesting because it's a bit of an art. So let's just start by trying to compute what 186 divided by 31 is. And of course, we could also write this as 186 divided by 31. Pause the video and see if you can figure it out. All right, now let's work through this together. I assume you've given it a go at it.
Yeah, I'll give it a go. Okay, right. Oh my god, just me passing. Dude. Okay, got a pen. This is pretty weird. I mean, you're gonna go definitely 186 anyway. Holy crap, it's pretty crazy. This goes 6 times. It's already 6. If I do 31 times 6, that's 186. Oh, that's pretty weird.
So I don't have my 31 times tables memorized, so I can't just immediately tell you the answer. But my brain tries to approximate these numbers so that my times tables knowledge does come in handy. For example, 31 is close to 30. And this is why I'm saying it's a bit of an art, but I'm saying, hey, look, this is pretty close to 30. And if I think about multiples of 30, well, those are just the multiples of 3 with an extra 0, or the multiples of 3 times 10. So the multiples of 30 are 30, 60, 90. Instead of 3 times 4 is 12. 30 times 4 is 120, 150 instead of 15, 180 instead of 18 for 30 times 6. And gee, this looks pretty close to 180. So this looks close to 30 times 6. And if this is close to 30, well, maybe this is going to be 6 right over here. And I'm going to put a question mark, because then the natural thing to do is to actually try it out. Figure out, what is 6 times 31? I'll put the question mark here again. Is this equal to 6? Well, the art part is we've made a good guess here. Now let's try to verify that maybe it is 6, maybe it isn't. So let's multiply 6.
Times 6.
Or let's multiply 31 times 6. 31 times 6. 1 times 6 is 6. And then 3 times 6, which is really 30 times 6, is going to be
180.
Right over here. So this is 186. So it all works out. 186 divided by 31 is indeed 6. We can get rid of this question mark here. Let's do another example. So let me delete that as well. Let's say we want to figure out what 336 divided by 48 is equal to. So pause this video
hard.
and see if you can figure it out. So the way...
So I guess I'm gonna turn it to 50. And then it's gonna be close to 6.
I would think about it.
Or 7. 6 or 7.
This thing right over here is close to 50.
Yeah.
Close to 50.
And this one's close to 340.
If you think about the multiples of 50, you have things like 300, which would be 50 times 6.
Yep.
And then you have 350, which would be 50 times 7, because 5 times 7 is 35. And so let's think about this. And actually, let me write these things down. If I were to say 50 times 6, that's the same thing as, well, that's going to be 5 times 6 times 10, which is 300. If I say 50 times 7, that's going to be 350. 5 times 7 is 35, and then you're multiplying that by 10. But this number is someplace in between 300 and 350. So my candidates for what this is going to be, well, I'm saying, hey, maybe this is 6, maybe this is 7. And what I would do is I would try out each of them. So let's try out 48 times 6. So let's try this first candidate out. 48 times 6. So 8 times 6 is going to be 48.
Yep.
4 times 6 is 24, plus 4 is 288. So that actually seems a good bit lower than this. It actually seems almost exactly 48 lower. So I could probably, I'm feeling pretty confident that I can squeeze another 48 into this. So I'm going to get, instead of being able to divide 6 48s into this, I'm feeling pretty good that maybe 7 is the answer.
Yeah,
let me try it out.
8 times 7 is about 6.
So 6 is not going to be my answer. I tried it out. Let me try 48 times 7. 48 times 7. 8 times 7 is 56. 4 times 7 is 28 plus 3. 336. That's exactly. 4 times 7 is 28 plus 3.
It's plus 5.
336. That's exactly right. So there you have it. With a little bit of trial and error, but it was an informed trial and error. We got 336 divided by 48 is equal to 7. This is what I meant. That it's a bit of an art.
Yeah, I guess. It's full of guessing and stuff. And estimation and stuff, yeah. Split up the area of a rectangle to help him solve a division equation. What equation did Cam's? Holy crap, this is hard. What am I supposed to do? Am I supposed to add this shit up? I think he solved. It's this guy, the large number that is dividing into something. Yeah, it's this one. Or this one. Oh my gosh, this is hard. Remainder 6? Alright, let's figure out total first. 400, 160, 172. Oh shit, I think it's gonna be this one. No, fuck, I made a mistake. It's B. It's kind of weird. I mean, 400 for 160. For 160. Oh shit! What did I just say? Oh my god, let me do it. Of course. Okay. Why did I use the thing? Mark will split up the area of the subdivision equation. So I guess that's 963 divided by 9. You get what? 107. What equation did Valerina solve? I think she's dividing 686 by 9 to get 854. Or by divided by, you get 9 remainder. That's so weird. What's up with this? Seven hundred. So weird, man. 7686. 854. Why would you have a remainder? Oh no. Oh, shit. Uh, 8. It's 9, right? So weird. A Amit split there out to solve a division equation. What equation did Amit solve? So it's dividing this guy into 7. Let's channel our focus once again. Okay, she's dividing 4115 by, it could be either of these. Let's see. Let's divide this by 4. I think this one's gonna have a remainder. You know what? Let's try. Oh shit. Someone's knocking again. Hey. Lina split up the area of a rectangle to help her solve a division equation. What equation did Lina solve? 5 by 4. Yeah. Mason split up the area of a rectangle to help him solve a division equation. 2739 divided by 3. Yep. Arya split up the area of a rectangle. Yep, okay. It's gonna be 800 8303. I'll start the quiz. Vera split up the area of a rectangle to help her solve the division equation. What equation did Vera solve? She's solving, or he, 3987. Okay, I guess this is it. There are 6 equal rows of buses. There are 24 total buses. Which expresses how many buses are in each row? It's gonna be 24 divided by 6. Wait, what? Oh, 6 equals row. Okay, that's correct. What is the value of k? 36 divided by 6 is 6. Cookie Monster has 27 cookies. He wants to divide the cookies in the jar so that each jar has 3 cookies. 9 jars with 3 cookies inside for each of the jars. Prachi split up the area correct. 756 divided by 7. Should be in 2 parts to this. Okay, so we have A, 100, and for B we have 8. Yeah, I mean 7 times 7 is 49. And for H, it's gonna be the combination of 108. So it's gonna be the answer, right? It's no remainder. Katie's making necklaces. Each necklace uses 5 beads. She has 25 beads in total. Use 5 beads. She can make 5 more beads by dividing 25 by 5. Then complete the equation. It's gonna be 7 divided by 7. I have 1000 divided by 7. I feel like I've done this before. And yep. There's 63 milk cartons. Each box holds 7 milk cartons. So how many boxes? So we have 63 divided by 7. Okay, cool. You're recording. I am. Okay. Take with 3 remainders.
Let's take the number 7 and divide it by 3. And I'm going to conceptualize dividing by 3 as let me see how many groups of 3 I can make out of the 7. So let's imagine, let me draw 7 things. 1, 2, 3, 4, 5, 6, 7. So let me try to create groups of 3. So I can definitely create one group of 3 right over here. I can definitely create another group of 3. So I'm able to create 2 groups of 3. And then I can't create any more full groups of 3. I have essentially this thing right over here left over. So this right over here, I have this thing remaining. This right over here is my remainder after creating as many groups of 3 as I can. And so when you see something like this, people will often say 7 divided by 3. Well, I can create 2 groups of 3, but it doesn't divide evenly, or 3 doesn't divide evenly into 7. I end up with something left over. I have a leftover, I have a remainder. I have a remainder of 1. So this is literally saying 7 divided by 3 is 2 remainder 1. And that makes sense. 2 times 3 is 6. So it doesn't get you all the way to 7, but then if you have your extra remainder, 6 plus that 1 remainder gets you all the way to 7. Let's do another one. Let's imagine 15 divided by 4. Let me draw 15 objects. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now let me try to divide it into groups of 4. So let's see, that's one group of 4. That's another group of 4. And then that's another group of 4. So I'm able to create 3 groups of 4, but then I can't create a 4th full group of 4. I am then left with this remainder right over here. I have a remainder right over here of 3. I have 3 left over. So we could say that 15 divided by 4 is 3 remainder 3. 4 goes into 15 3 times, but that only gets us to 12. 4 times 3 is 12. To get all the way to 15, we need to use our remainder. We have to get 3 more. So 15 divided by 4, I have 3 left over.
Wait, why does it say you haven't completed it?
Over.
Some division problems work out nicely. Yep, that's true. Just work out nicely. Oh no, we can split in perfect groups of 7. We have some circles left over. How many groups of 7 can we make? We only make 3. How many remain? How many are not in the group? 4. Can you just remain to describe what remains after dividing? 3 or 4. Okay, it's gonna be 2 and 1. See? I pressed 1 one time only. But it doubled. I hate it. Can mess things up. Okay. It's gonna 4. We have 2 remainder. Okay, that's gonna be 3. Again, 1 remainder. It's gonna be 5. And 3 remainder. That's gonna be, oh shit, it's hard. I think it's gonna be 6. We have 6 remainder. Oh shit, is that right? No, 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 no. Yeah, I mean 6 times 7 is like 42. So 6 times 6 32, and then we have 5 here. I mean 6 36. Yeah, that's correct. Challenge, try this game. Oh shit, I just clicked. Your goal is to figure out the remainder of the division problem shown on the screen. Once you know the answer, rotate the shape so that the edge with the answer is at the bottom. Oh shit, what the fuck? Holy, what the fuck? What the fuck is this? What is this? No idea what the fuck is happening. Wait, wait, wait. Your goals to, man. What does this even mean? What the freak? I don't even get the game. What the heck? Okay, let's try again. Your goal is to figure out the remainder of the division problem. What is the division problem here? Click this. What does this even mean? What does this even mean? What the fuck's this bullshit? And I just won, and I don't even know what I did. See? The fuck? What the fuck was even the division problem there? You have 5, 4, we have 20 stuffs happening here. What the what? I don't know what that is. This what remain. Yeah, but what do remainders mean in the real world? The answer is currently distinct through some examples. Charlie has $17 to spend on chocolate bars. Charlie buys as many chocolate bars as again with his money. Brown describes the remainder in this situation. The amount of money Charlie has left over. A carnival ride holds 5 people at a time. There are 30 people in line to ride the ride. Peter Brown describes the remainder in this situation. The number of people. What? On the last ride. There are 13 penguins going on a field trip. I'm running, right? I keep on checking, so I'm getting paranoid. Okay. There are 10 penguins going on a field trip to an iceberg. The penguins get into 6 equal groups. How many penguins will be in each group? How many pies can James make? Can make 6 pies. What? James is 41 apples to make apple pies. Each pie needs 7 apples. Oh shit, it's 5. I mean 642. Dang. Fill in the blanks. Yeah, it's gonna 5, 6. Hot dogs. Soup, grilled chicken, and hot dogs. 9 people eat 3 hot dogs each. How many hot dogs are left over? So it's gonna be 2 hot dogs left over. So it's gonna be 3 with 2 hot dogs left over. Next video.
Let's divide 3,771 by 8. So, and we're going to do a little bit of long division, so the way we set it up. So the first thing we want to do and think about, well, does 8 go into 3? Well, no, 8 does not go into 3, so we'll keep moving. Does 8 go into 37? Sure, 8 times 4 is 37. Sure. 8 times 5 is 40, so that's too big. So 8 goes into 37. 8 goes into 37 4 times. 4 times 8 is 32. And we subtract, and we get 37 minus 32 is 5. And just so you have a little glimpse of what's actually going on here, we're really saying how many times does 8 go into 3,700? And we're saying that 8 goes into 3,700 400 times. There's 4 sitting in the hundreds place. And that 400 times 8 is 3,200. And that when you subtract 3,200 from 3,700, you're getting 500. But we'll revert back just the traditional long division mechanics. But that's what's really going on here. 8, when we say 8 goes into 37 4 times, we're really saying 8 goes into 3,700 400 times. But let's keep going. So now we have this 5 to deal with, which is, as we already talked about, it's in the hundreds place, so it's really a 500. But now let's bring down another place value. So let's bring down the 7. And let's think about how many times does 8 go into 57.
We go 7 times.
We're really thinking about how much
the 6
goes into 570. But 8 goes into 57. Let's see. 8 times 5 is 40. 8 times 6 is 48. 8 times 7 is 54. So let's go 7 times. 7 times 8.
Wait, what? 54?
We've already... Oh, actually, I did that right. 8 times
it's 56.
7. 8 times my multiplication.
Oh, yeah. You got wrecked by me, Sal.
So it does go into 7 times, but 7 times 8 isn't 54.
Yeah, it's 56, man.
I always have trouble with that one. It is 56. And so now we subtract again. And 57 minus 56 is 1. And now we have one more place value to bring down. We have... Let me do the color I haven't used yet. I'll do blue. We have a 1 to bring down. And now we're literally saying, how many times does 8 go into 11? Well, 8 goes into 11 one time. 1 times 8 is 8. And we are left with,
remainder.
We have no more places to bring down. 11 minus 8 is 3. So 8 goes into 3,771 471 times. And the remainder is... The remainder here is 3.
Okay, cool. The problem I have is, why does this video complete? What the heck? So let's watch it.
Over. Let's take the number 7 and divide it by 3. And I'm going to conceptualize dividing by 3 as, let me see how many groups of 3 I can make out of the 7. So let's imagine, let me draw 7 things. 1, 2, 3, 4, 5, 6, 7. So let me try to create groups of 3. So I can definitely create one group of 3 right over here. I can definitely create another group of 3. So I'm able to create 2 groups of 3. And then I can't create any more full groups of 3. I have essentially this thing right over here left over. So this right over here, I have this thing remaining. This right over here is my remainder, after creating as many groups of 3 as I can. And so when you see something like this, people will often say 7 divided by 3. Well, I can create 2 groups of 3, but it doesn't divide evenly, or 3 doesn't divide evenly into 7. I end up with something left over. I have a leftover, I have a remainder. I have a remainder of 1. So this is literally saying 7 divided by 3 is 2 remainder 1. And that makes sense. 2 times 3 is 6, so it doesn't get you all the way to 7. But then if you have your extra remainder,
if I remember, the next example is 15 divided by 4, so 3 remainder 3.
7. Let's do another one. Let's imagine 15 divided by 4. Let me draw 15 objects. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now let me try to divide it into groups of 4. So let's see, that's one group of 4. That's another group of 4. And then that's another group of 4. So I'm able to create 3 groups of 4, but then I can't create a 4th full group of 4. I am then left with this remainder right over here. I have a remainder right over here of 3. I have 3 left over. So we could say that 15 divided by 4 is 3 remainder 3. 4 goes into 15 3 times, but that only gets us to 12. 4 times 3 is 12. To get all the way to 15, we need to use our remainder. We have to get 3 more. So 15 divided by 4, I have 3 left over.
Hopefully it got checked. Ah, thank you. Long division
Never hurts to get a
2000.
lot of practice. So in this video, I'm just going to do
Oh.
a bunch more of essentially what we call long division problems. And so if you
10
have
minutes.
4 goes into 2,000.
Holy crap. People kept knocking. Okay, I'm back.
292. And I don't know exactly why they call it long division, and we saw this in the last video a little bit. I didn't call it long division then, but I think the reason why is you could think it takes you a long time, or it takes a long piece of your paper, or you kind of as you go it takes you a long
Yeah,
time, or
go back a bit.
it takes a long division then. But I think the reason why is you could think it takes you a long time, or it takes a long piece of your paper, or you kind of as you go along, you kind of have this thing that get this long tail that develops on the problem. So all of those are at least reasons in my head why it's called long division. But we saw in the last video that it's a way to tackle any division problem while just knowing your multiplication tables up to maybe 10 times 10 or 12 times 12. And just as a bit of review, this is the same thing as 2,292 divided by 4. And it's actually the same thing, and you probably haven't seen this notation before, as 2,292 divided by 4. This, and this are all equivalent statements on some level. And as you can see, you say, hey, Sal, that looks like a fraction, in case you have seen fractions already, and that is exactly what it is. It is a fraction. But anyway, I'll just focus on this format, and in future videos, we'll think about other ways to represent division. So let's do this problem. So 4 goes into 2 how many times? It goes into no times. So let's move on to, let me switch colors. So let's move on to the 22. 4 goes into 22 how many
5
times?
times.
Let's see, 4 times 5. 4 times 5 is equal to 20. 4 times 6
Plus
is equal
24.
to 24. So 6 is too much. So 4 goes into 22 5 times. 5 times 4 is 20. There's going to be a little bit of a leftover. And then we subtract. 22 minus 20, well, that's just 2. And then you bring down this 9. And you saw in the last video exactly what this means, right? When you wrote this 5 up here, notice we wrote in the hundreds place. So this is really a 500. But in this video, I'm just going to focus more on the process. And you can think more about what it actually means in terms of where I'm writing the numbers. But I think the process is going to be crystal clear, hopefully, by the end of this video. So we brought down the 9. 4 goes into 29 how many times?
7 times.
4, it goes into at least 6 times. What's 4 times 7? 4 times 7 is 28. So it goes into it at least 7 times. What's 4 times 8?
32.
4 times 8 is 32. So it can't go into it 8 times, so it's going to go into it 7. 4 goes into 29 7 times. 7 times 4 is 28. 29 minus 28 to get our remainder for this step in the problem is 1. And now we're going to bring down this 2. We're going to bring it down. And you get a 12. 4 goes into 12. That's easy. 4 times 3 is 12. 4 goes into 12 3 times. 3 times 4 is 12.
Got no remainder.
12 minus 12 is 0. We have no remainder. So 4 goes into 2,292 exactly 573 times. So this 2,292 divided by 4 we can say is equal to 573. Or we could say that this thing right here is equal to 573. Let's do a couple more. Let's do a few more problems. Let me pick a nice, do that red color. Let's say we had 7. 7 going into 6,475.
I'm gonna follow along.
Maybe it's called long division because you write it nice and long up here in this line. I don't know. Reasons why it can be called long division. So you say 7 goes into 6 0 times. So we need to keep moving forward. So 7, so then we go to 64. 7 goes into 64 how many times? Let's see. 7
9.
7 times 7 is, well, that's way too small. Let me think about it a little bit. Well, 7 times 9 is 63. That's pretty close. And then 7 times 10 is going to be too big. 7 times 10 is 70.
Okay, so
So
925 is
that's
the
too
answer.
big. So 7 goes into 64.
I did the same shit.
9 times. 9 times 7 is 63. 64 minus 63 to get our remainder at this stage is 1. Bring down the 7. Bring down the 7. 7 goes into 17 how many times? Well, 7 times 2 is 14. And then 7 times 3 is 21. So 3 is too big.
Too big, yeah.
So 7 goes into 17 2 times. 2 times 7 is 14. 17 minus 14 is 3. And now we bring down the 5. We bring down the 5. And 7 goes into 35. That's in our 7 multiplication tables 5 times. 5 times 7 is 35. 5 times 7 is 35. And there you go. And so the remainder is 0. So all the examples I did so far had no remainders. Let's do one that maybe might have a remainder. And to ensure it has a remainder, I'll just make up the problem. It's much easier to make problems that have remainders than the ones that don't have remainders. So let's say I want to divide 3. Let's say I want to divide 3 into, I'm going to divide it into, let's say 1735092.
Holy
This is a
shit.
nice beastly problem. So if we can do this, we can handle everything. So this is 1,735,092. That's what we're dividing 3 into. So
Let's see if we're gonna get the same
3
answer.
goes, actually, I'm not sure if this will have a remainder. And in the future video, I'll show you whether how to figure out whether something is divisible by 3. Actually, we can do it right now. We just add up all these digits. 1 plus 7 is 8.
Holy
8
shit.
plus 3 is
Oh,
11.
it's 22.
11 plus 5 is 16. 16 plus 9 is 25. 25 plus 2 is 27. So actually, this number is divisible by 3. So if you add up all of the digits, you get 27, and then you can add up those digits. 2 plus 7 is 9. So that is divisible by 9. That's a trick that only works for 3. So this number actually is divisible by 3. So let me change it a little bit so it's not divisible by 3.
Wait, what?
Divisible by 5 plus 7 is a remainder. And in the future video, I'll show you whether how to figure out whether something is divisible by 3. Actually, we can do it right now. We just add up all these digits. 1 plus 7 is 8. 8 plus 3 is 11. 11 plus 5 is 16. 16 plus 9 is 25. 25 plus 2 is 27. So actually, this number is divisible by 3. So if you add up all of the digits, you get 27, and then you can add up those digits. 2 plus 7 is 9. So that is divisible by 9. That's a trick that only works for 3. So this number actually is divisible
2
by 3.
plus 7
So let me change it a little bit so it's not divisible.
Oh, that's
by
very
3.
weird. Very cool
Let
trick.
me make this into a 1. Now this number will not be divisible by 3. I definitely want a number where I'll end up with a remainder, just so you see what it looks like. So let's do this one. 3 goes into 1 0 times, so we can just move forward. You could write a 0 here and multiply
5.
that out, but that just makes it a little bit messy in my head. So 3, so we just move 1 to
8.
the right. 3 goes into 17 how many times? Well, 3 times 5 is equal to 15, and 3 times 6 is equal to 18, and that's too big. So 3 goes into 17, or right here, 5 times. 5 times 3 is 15, and we subtract. 17 minus 15 is 2. And now we bring down this 3. Set 3 goes into 23 how many times? Well, 3 times.
Holy shit, I think I already made a mistake. I'm getting cramped over here tonight. I'm gonna solve it. I'm gonna try to solve it. Basely number. 1,700. No, it's so 1,000. What the hell am I saying? What is this number anyway? It's a million, holy shit. Okay. So it goes 17 to 5 times. And 15. And we have 2. Bring down 3. Then it goes 7 times. Then 1. Then 3 minus 1, we get 2. Then bring down 5. So it goes 8 times. So it's gonna be 24. Then 5 minus 24 is 1. Bring down 0. You have 10. And then 3 goes in 10 3 times. It's gonna be 10 minus 9. Gonna be 1. Bring 9 1. We got 9. 9. Wait. What am I doing? 9. It's not 9. For 19, I think it's oh shit, 6. 6 gonna give us 18. 19 minus 8 is 1. Then bring down 1. So we got 3. So 3 times 3 is 9. Minus 2, minus 9. 11 minus 10 is 2. So we have remainder 2. So my answer is, what is this number? 578,363 remainder 2.
7 is equal to 21. And 3 times 8 is too big. That's equal to 24.
Where's
So
my
3
pencil?
goes into 23 7 times. 7 times. 7 times 3 is 21. And we subtract. 23 minus 21 is 2. Now we bring down the next number. We bring down the 5. I think you can appreciate why it's called long division now. We bring down this 5. 3 goes into 25 how many times? Well, 3 times 8 gets you pretty close.
Yep.
3 times 9 is too big. So it goes into it 8 times. 8 times 3 is 24. I'm going to run out of space. You subtract, you get 1. 25 minus 24 is 1. Now we can bring down this 0. You bring down this 0, just like that. And you get 3 goes into 10 how many times? Well, that's easy. It goes into it 3 times. 3 times 3 is 9. That's about as close to 10 as we can get. 3 times 3 is 9. 10 minus 9. I'm going to have to scroll up and down here a little bit. 10 minus 9 is 1. And then we can bring down the next number. I'm running out of colors. I can bring down that 9.
You get 19.
3 goes into 19 how many times?
6 times.
6 is about as close as we can get. That gets to 18. So 3 times 6. 3 goes into 19 6 times. 6 times 3. We scroll down. 6 times 3 is 18. 19 minus 18, we subtract it up here too. 19 minus 18 is 1. And then we're almost done. I can revert back to the pink. We bring down this 1 right there. We bring down that 1.
Hey,
3 goes into 11.
same process that I
That's
did.
3 times, because 3 times 4 is too big. It's 3 times 4 is 12,
12,
so that's
yep.
too big. So it goes into 3 times. So 3 goes into 11. 3 times 3
It's 9.
is 9. And then
So
we
11
subtract, we get
got 2.
a
2 remainder.
And there's nothing left to bring down, right? And when we look up here, there's nothing left to bring down, so we're done. So we're left with a remainder of 2 after doing this entire problem. So the answer
Oh, it's pretty
3
sick.
goes into 1,735,091. It goes into it 578,363.
8,363 remainder 2. Yeah, boy, got it.
That remainder 2 is
Why am I so proud? This is some elementary stuff.
down.
Yeah,
So
I'm
hopefully
proud
you
of
now
me.
appreciate that you can tackle pretty much any division problem, and you also, through this exercise, can appreciate why it's called long division.
True. Okay, let's start. There's a it's gonna be 6. No, it's 7. And minute 3. Cool. Okay, cool. Divide multi number 6, 7, 8, 9 remainders. Okay. Oh shit. Okay, let's do this. 2, 7, 5, 8. It's okay. 7 goes to 27 3 times, and I get 21. We're gonna subtract that. We get 6. Then got 65. That's correct, not 6. 9. 63. So we get 2. 28. We got 4. 8. 0. There's no remainder. What the fuck? I'm supposed to say 0, right? Yeah. Uh, 4008 divided by 9. 5 times. Yeah, 40. 0. Then we're 0. So 0 times. 0. We have 0. 8. Wait, what the hell am I doing? I would just write 500 minus 8. What? You kidding me? The freak? What? Is this wrong? Dude, this is sick. Oh shit. 8. If this is 8, it would go 5 times. This is wrong. It's not 5. Let's go 4 times. 36. Because 5, it's 45. 9 times 5 is 45. God damn it. Four, 4, 4. Wait, what? Holy shit, this is so weird, man. Did it just bring down 0 twice? Oh my god, yeah, I did. Oh my gosh, I'm an idiot. Funny. Maybe being too hasty. I shouldn't be. It goes to 48 6 times. Yeah, it's 48. It's 48 and 0, 3 and 3. 0. 0. 32, man. Let's go 4. 604, no remainder. 5, 6, 9, 8 divided by 8. 7. 1, 18, 2, and then yeah, we have 7, 1, 2, remainder 2. Cool. Multi-digit division, holy shit. Oh man, this is hard. Okay. Salkan's approaches guessing. The heck? Can I really do this? Just by writing. What the freak? Oh my gosh, this is hard. Dude. I need to know your major. Some. Oh crap, okay. Okay, let's do the guessing. If I do 20, and then multiply 20 by, let's say, oh, I don't know. Holy crap. By, I don't know how much do I need to multiply to get close. That's very close. 20 plus 600. So just gonna multiply by 30. So let's try 18 times 20, let's do 27. Of course we got 6, 7, 12, 16, 2, 1. The fuck? It's so weird. No. 18 times 30, right? 2 times 30. It's gonna be 24. 540. Okay, we're getting close. If I add 2 more, it's gonna be 32, right? 18, 32. 16, 2, 3, 0, 4, 2, 3, 5, 6, 7, 5, 7, 6. Okay, we're gonna do 32. And then if I add 18, 5, 7, 6 plus 18, we're gonna have 4, 7, 8, 594, so it's 7 to 32. So how much is the difference between 576 and 86? It's gonna be 10, remainder 10. Holy shit, this is hard. So 24 times 10 is 140. So I can afford 11. 279 times 11. 97297. We have 9, 16, 10, Wait, why am I multiplying? Oh my god. 24. Oh my god. Two six four and our remainder is 264. The difference is 10 and 5. It's gonna be 15 difference, right? 2 plus 10 is gonna be 274 plus 5 79. Oh shit, that's hard. Let's see, this goes to 4. 72 times 400. What if I try to do the long division? 5 6. Right? Those 4 is gonna be 38. That is gonna be 88. What about 3? What about 66? And if we minus that, 30, it'll be, no, it's 14, 7, 8, and 18. I'll bring down to 5. That's 22. 22 times 5. Uh, 20 times. Holy crap, this is so fucking hard, man. Times 22 times 6 is 120. I can use. Let's try 6. Not 12. Times 8. No, 16. 16. 17. 8. God damn, this is hard. Okay. 16, 17. It's gonna be a difference of 9. Oh shit, 96. It goes into it 4 times. We have 88. 8. So creative 4, remainder 8. But let's make sure. 384 times 22. Wow, we have 8. Yep. We have 8, we have 16, 7, we have 8, we have 16. It's 8448. 8448 plus 8 is 8456. Got him. Okay. God damn, it's so hard. think 7 times plus. Let's try it. So it's 370. No, let's try to multiply first. 370 times 22. 0 4 1 6 7 0 0 shit 4 0 4 11 8140 plus 2 8142 8142. Nice. 370 remaining. Yeah. That's hard, man. Gonna complete this one and then I'm done.
Let's divide 9,815 by 65, or figure out how many times does 65 go into 9,815. And I encourage you to pause this video and try this on your own. So let me just rewrite this as 9,815 divided by 65. Divided by 65, and we write it this way because it's easier to manipulate the numbers, kind of doing the standard process here. And as we'll see, whenever we divide by a number that has more than one digit, there's a little bit of an art to it, and hopefully you'll get an appreciation for that art over the course of this video. So first we can think about, well, how many times does 65 go into 9? Well, it doesn't go into 9 at all, so we can move one digit to the right. How many times does it go into 98 without going over it? Well, 65 times 1 is 65, so that doesn't go over it. And 65 times 2, well, that's 130, so that would go over 198, so it only goes one time. It only goes one time. We multiply 1 times 65, which is 65, and then we could subtract to see how much we have left over. So 8 minus 5 is 3, and 9 minus 6 is 3, and now we can bring down the next digit, this 1 here. And now this is where the art is going to come into play, because we need to figure out how many times does 65 go into 331 without going over it. And you might just try to look at these numbers, try to approximate them a little bit. You might say, well, maybe 65, well, let me round this thing up. Maybe this is close to 70, and let's see, this is close to 300. So maybe we say, well, 70 would go into 300. So maybe we think about how many times does 70 go into 300, and we say without going over it, it doesn't go exactly into 300. Well, you can say, well, how many times does 7 go into 30? Well, we know 7 goes into 30 4 times. 4 times 7 is 28. So maybe try a 4 right over here, because then this will be 280. 4 times 70 is 280. You're still going to have a little bit left over, but what you have left over is going to be less than 70. It's going to be 20. So you say, well, if this is roughly 70, and if this is roughly 300, then maybe it's going to be the same thing. So let's try that out. Let's see if it goes 4 times. So 4 times 5 is 20.
It's 132.60.
4 times 6 is 24, plus 2 is 26. And now let's see how much we had left over. So when you subtract, we are left with, at least in a new color, 1 minus 0 is 1. We have a 3 here and a 6 here, so we're going to have to do a little regrouping. Let's take 100 from the hundreds place. It becomes 200. Give those 10 tens, that 100, to the tens place.
It's more than
13 tens.
It's 7.
13 minus 6 is 7, and then 2 minus 2 is 1. So did this work out?
2 minus 2 is 1.
Well, no, our remainder, and then 2 minus 2 is 1. So did this work out? Well, no, our remainder, after we said it went in 4 times, we actually had 71 left over. 71, this right over here, is larger than 65. You don't want a situation where what you have left over is larger than what you were trying to divide into the number. You could have gone into it one more time, and because you had so much left over. So this 4 was actually too low. We should have probably approximated this as 60, and 60 goes into 300. If we were to estimate, we'd say, well, that might be closer to 5 times. So this is where the art of this comes into play. So it was very reasonable to do what I just did, but it just turned out to not be the right way to think about it. I could just say, well, 4 wasn't enough. I had too much left over. Let me try 5 now. 5 times 5 is 25. Carry the 2. 5 times 6 is 30, plus 2 is 32. There you go. We got much closer to 331 without going over. Now we can subtract. And once again, we can do a little regrouping. Take a 10 from the tens place. This becomes 2 tens. This becomes an 11. 11 minus 5 is 6. 2 minus 2 is 0. 3 minus 3 is 0. So we only have 6 left over, which is obviously less than 65, so we're all good. And if we put a 6 here, and we would have gone over 331, and so that wouldn't have been cool either. But anyway, let's bring down the next digit. Let's bring down the 5. So how many times does 65 go into 65? Well, it goes one time. 1 times 65, and we can ignore this, that's from the previous step. 1 times 65 is 65, and then you subtract, and we have no remainder. No remainder. So we see that 65 goes into 9,815, exactly 150, let me just write that in that same blue color. 100 and, I don't want to do all these arbitrary colors, 151 times. 151 times. Let's divide 7,182 by 42. And what's different here is we're now dividing by a 2-digit number, not a 1-digit number, but the same idea holds. So we say, hey, how many times does 42 go into 7? Well, it doesn't really go into 7 at all, so let's add one more place value. How many times does 42 go into 71? Well, it goes into 71 one time. And we're really, just a reminder, I'm just doing the process where we say, hey, 42 goes into 71 one time, but we're really saying 42 goes into 7,100 100 times, because we're putting this one in the hundreds place. But let's put that on the side for a little bit and focus on the process. So 1 times 42 is 42, and now we subtract. Now, you might be able to do 71 minus 42 in your head, knowing, hey, 72 minus 42 would be 30, so 71 minus 42 would be 29, but we could also do it by regrouping. To regroup, you want to subtract a 2 from a 1. Well, that's not so. You
Wait,
can't
what did you say?
Regrouping. It would be 30, so 71. You might be able to do 71 minus 42 in your head, knowing, hey, 72 minus 42 would be 30, so 71 minus 42 would be 29, but we could also do it by regrouping. To regroup, you want to subtract a 2 from a 1. Well, that's not so. You can't really do that. And
70.
Traditional group, 21 minus 42 would be 29, but we could also do it. A 72 minus 42 would be 30, so 71 minus 42 would be 29, but we could also do it by regrouping.
Oh, it's pretty sick.
To regroup, you want to subtract a 2 from a 1. Well, that's not so. You can't really do that in any traditional way. So let's take a 10 from the 70, so that becomes a 60, and give that 10 to the ones place, and then that becomes an 11. And so 11 minus 2 is 9, and 6 minus 4 is 2, so you get 29. And we can bring down the next place value, bring down an 8. And now this is where the art happens when we're dividing by a multi-digit number right over here. We have to estimate how many times does 42 go into 298. And sometimes it might involve a little bit of trial and error. So you really just kind of have to eyeball it. If you make a mistake, try again. The way you know you make a mistake is if you say it goes into it 9 times,
190 remainder is the answer.
298, then you overestimate it. If you say it goes into it 3 times, you do 3 times 42, you get some number here. When you subtract, you get something larger than 42, then you also made a mistake and you have to adjust upwards. Well, let's see if we can eyeball it. So this is roughly 40. This is roughly 300. 40 goes into 300, the same times as 4 goes into 30, so it's going to be roughly 7. Roughly 7. Let's see if that's right. 7 times 2.
Wait,
7.
what? How did you get
40
7?
goes into 300, the same time is 4 goes into 30, so it's going to be roughly 7. Roughly 7. Let's see if that's right. 7
Dude, I did
times
9.
2 is 14. 7 times 1 is 28, plus 1 is 29. So it got pretty close. My remainder
Oh
here,
shit, I think I
notice
made a
294
mistake.
is less than 298, so I'm cool there. And my remainder is less than 42, so I'm cool as well. So now let's add another place value.
Oh shit, I made a mistake, definitely.
Let's bring this 2 down. And here we're just asking ourselves, how many times does 42 go into 42? Well, 42 goes into 42 exactly one time. 1 times 42 is 42, and we have no remainder. So this one luckily divided exactly. 42 goes into 7,182 exactly 171 times.
Okay, so if I do 5, then it's gonna be 155. So we can do 150 with remainder 10. Oh my god, I don't want to make a mistake here. Oh shit, we're not 150, it's 5. Remainder 10, right? So 5 times 31 is... Yeah, I did 30, so it's gonna be like... Oh my god. Yeah, okay, good. It's pretty sick. So I can guess that it's this close to 20. If we do 6, we can have like 2, 4, 6, 10. And yeah, I can do another 17. So this is 7 with no remainder. So let's try that if it's really indeed. It's 49. Yeah, 4, 7, 11. Okay. So 235 to 235. Oh shit. Very sick. Gonna eyeball again. So let's try 32. So if this was just 30, then the closest I can get for 3 is gonna be 7. Maybe 2, 10. Let's try 7. 14. Uh, yep, I did 21. Yeah, that's pretty close. That's just 7. 2, 2, 4. It's gonna be difference 9. Maybe 9. It's 11. The remainder 11. Now let's try to do it the other way around, because I don't want to make a mistake now. It's gonna 14, 21, 22 plus 11, 235. Okay. 1 to 8 divided by 16. 16. So we're gonna do more eyeballing. So if this was 20, and then I try 4, okay, let's do 5, 30. Kidding me? This is 80. It's pretty sick. Yeah, I guess. 16 times 5. If you do 8, we got 8, 4. Holy shit. Got 8, 0 remainder. Yeah, that's correct. I noticed was because binary thing. Times 10 is 130, so times 9 is pretty close. No 7. 2, 9, 11. 1, 7. It's been 9, 2. Okay, it's gonna be 100. Ah, it's just 5. Let's say 11. It's 9, remainder 5. Yep, because if I add 5 here. Nope. It's not. Oh, fuck. Why is this 8 and then here it's 7? Let's do this. 3, 13. We have 9, 7, 2, 9. It's 11. It's gonna be 13. It's gonna be 1. All dice out, so we have 5 left. Okay. 5. What? What the? God damn it. 0 times, 0 times. 1 to 3, if we go 9. We have 9 times 3 into 7. We have 2 here with 9. Plus 2 with 11. Top all that thing. 7, 6. Oh shit. 13 minus 7, why did I say 5? Oh, god damn it. 2 to 5 and 1 to 5. Oh. It's been 9. If we do like 20 times 9, it's 180. 9 maybe 6. If we do the 6 times, 2, 4, 12, 4, yeah, maybe 6 times, then, let's preserve, 2, 4, 12, 16, 4, 162, difference is 7. No, it's 7. Plus 10, plus 10, plus 10 is 172 plus 3. So, okay. Let's go 19 times 6. Let's do 5. 5. 4. It's 95. Let's do 4 19 times 6. Oh shit, it's exactly 6. This is 8. No, not 96. 13. Okay, I don't want to make a mistake for this last one, so I'm gonna double check. So 14, 2, 3, 11, 8 times, plus 10, 22 plus 3, 25. Yeah, cool. Crap, it's already 12. Right. Dang, my hair sucks. How much left? Oh shit, it's the last one. I'm gonna do this.
We are told there are 10 students in the poetry club. This week, each student wrote 2 poems. What does the expression 10 times 2 represent? And they give us some choices. Pause this video and see if you can work that out. Alright, so there are 10 students in the poetry club, and each student wrote 2 poems. So I would use 10 times 2 to figure out, hey, for each of those 10 students, if they each wrote 2 poems, then we have 10 times 2 total poems. And if we look at the choices, that is choice C right over here. If we look at choice A, the number of students is 10. It wouldn't be 10 times 2. And then the number of poems each student wrote, well, that's the second piece of information. They each wrote 2 poems. That wouldn't be 10 times 2 either. Let's do another one of these, a little bit different this time. So now we're asked, let me scroll this over a little bit, which problem can we solve with 3 times 8? So pause this video and have a go at it before we do it together.
Okay. Ellen said 8 pieces of gum. She ate 3 pieces at school. How many pieces of gum does Ellen have now? No. No. Not this ones.
All right. Now let's read these and see if you can solve it with 3 times 8. Ellen has 8 pieces of gum. Fair enough.
Subtraction.
She ate 3 pieces at school. If she didn't swallow the gum, that can be problematic. How many pieces of gum does Ellen have left? So would you use multiplication for that? The way I would tackle it, she has 8 pieces of gum. And if she ate 3, and we want to figure out how much gum does she have left, I'm assuming outside of her body, well then I would subtract 3 from 8. I wouldn't multiply 8 by 3, so I would rule this one out. That's not going to be my choice. I'm not going to solve this problem with multiplication, or at least by 3 times 8. Brendan has 8 t-shirts. Fair enough. That's about how many I have. He goes to the store to buy 3 more t-shirts. How many t-shirts does he have now? Would I solve that with multiplication? Let's see. The way I would solve it is he has 8 shirts, and then he's buying 3 more. I would add 3 to figure out how many total t-shirts he has. I wouldn't multiply by 3, so I'd rule that out. So let's see how choice C is looking. There are 8 chocolates in each box. Mike has 3 boxes of chocolates. How many chocolates are there? So this is interesting. So he has 3 boxes of chocolates. So let me draw those boxes. 1 box, 2 box, 3 boxes of chocolate, and each of them have 8 chocolates. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Well, yeah, if I want to figure out how many total chocolates there are, I have 3 groups of 8. I would solve that by multiplying 3 times 8. So I like this choice a lot. Let's do another example. Here, we are told Gerald is going to plant a garden this spring. That's a good thing to be doing. He plans to have 7 plants in each row. There will be 8 rows. Which expression can Gerald use to find the total number of plants needed for his garden? Pause this video and see if you can figure that out.
Yeah, it's A.
All right, I'll do a little bit of a drawing. I'll do it in green because we're talking about rows of plants. So 7 plants in each row, and there will be 8 rows. So 1, 2, 3, 4, 5, 6, 7. 7 plants in each row, and then we're going to have 8 rows. So let me copy and paste that. So that's 2 rows. That's 3 rows. That is 4 rows. getting there. 5 rows. 6 rows. 7 rows. And 8 rows. So we don't have to actually calculate it, but the way you could think about it is you have 7 plants in each row, and then you have 8 rows of plants. 8 rows of plants. So if you want to figure out the total amount, you would multiply 8 times 7. And so let's see, that's this first choice right over here. You would multiply 8 times 7 times 7. And 8 plus 7 is definitely not going to give you the total number of plants here. So yeah, we like using the 8 times 7. And we're done. Beatrice is ordering pizzas for a party. Each pizza is cut into 12 pieces. Beatrice wants to have enough pizza so that each person can have 4 pieces. And 16 people will be at the party. A lot of information in this problem. If Beatrice buys 7 pizzas, how many extra pieces will there be after each person eats 4 pieces? So to do this, let's think about how many total pieces she will have.
So we have 7 times
And then
12.
let's think about how many total pieces will be eaten by the 16 people. And then we'll figure out how much that she had extra.
So we have
first, let's think about how many
pieces,
total
and there will be 16
pieces.
people.
And I
So
encourage you to pause the video and try to figure it out
84
yourself.
divided by 16.
She ordered
by 16, and then if we multiply 16 by 5, I got 30. 3, 5, 80. Wow, it's pretty close. And then we have 4 left.
ordered 7 pizzas. How many total pieces are there going to be? Well, you have 7 pizzas. 7, that's the number of pizzas. And if you...
Wait, what? So, Beatrice, each pizza is cut into 12 pieces. Okay. Can have 4 pieces and 60 people to the party. Okay. So, I have 7 pizzas. Okay, so 7 pizzas and then 12 pieces. 7 times 12 is going to be 84, as seen here. And then there would be 4 people and 16. Oh, there's no divisions happening here. So 16 people, and for each people we have 4 pieces. It's gonna be 16 times 4. Here's 64. So what we're gonna do is 64 minus 84 minus 20 pizzas left.
If you have...
So it's gonna be 20 pizzas left.
Pieces per pizza, you multiply by 12 to get the total number of pieces. So this is number of pieces per pizza. And 7 times 12 is equal to 84 total pieces. Total pieces. So that's how many pieces she's got. Now let's think about how many get eaten by the 16 people. So you have 16 people. 16, that's the number of people. This little symbol, that's shorthand for number. 16 people, and they each eat 4 pieces. So 16 people times 4 pieces per person. So number of pieces per person. Pieces per person. 16 times 4 is 64. So that's 64, not 84, 64. 64 pieces are eaten by the 16 people.
So
how much does she have left over? Well, if you start with 84 pieces and 64 get eaten, 84 minus 64 is 20. So you have, we deserve a drum roll now. You have 20 pieces that are going to be, or 20 extra pieces after everyone eats their share.
Cool. Ah, so it's division.
Blair scored 144 points this football season. He scored all his points with 50-yard field goal. That's actually pretty impressive. 50, that's like close to record breaking, and even in the National Football League, I think the record's like 60 yards or something. So that's Blair seems like a fairly impressive individual. He scored all of his points with 50-yard field goal kicks. 50-yard field goal kicks. I'm just underlining that because I'm impressed by how far those field goals are, which are each worth 3 points. So a field goal in American football, I should clarify for those of you from other countries who think we're talking about soccer, a field goal is worth 3 points each.
I don't even know those two games, and heck, I'm just gonna try to solve this on my own first. So Blair scored 144 points this football season. He scored all his points with 50-yard goal kicks, which are worth 3 points each. He played in 16 games this season. How many goals did Blair make in each game? I assume he made the same number in each game. So each goal is 3 points each, and we have 144 points. How many goals did So we can divide the 144 by 3 first. I think we should do that. So with 48, and then we're gonna divide 48 by 16, which will give us 3, I suppose. 16 times 3, 16 times 18. Yeah. So Blair made like 3 goals in each game.
In 16 games this season. How many field goals did Blair make in each game? Assume he made the same number in each game. So this guy
it's gonna be 3.
is an incredibly consistent field goal kicker. He makes 50-yard field goals. He makes the same in every game. So let's think about how many field goals did he make in each game. So there's a couple of ways you can do this.
50-yard one is
well, how many field goals did he make in the
not
season?
needed.
So he scored 144 points. He scored 144 points total. And if we divide that by 3, we divide that by the fact that a field goal gets you 3 points per field goal. So the total number of points divided by the points per field goal, this should give us the total number of field goals he had. So this right over here is going to be equal to
48.
So 3 goes into 144. Let me do this on the side right over here. 3 goes into 144. 3 goes into, doesn't go into 1, it goes into 14 4 times. 4 times 3 is 12. Subtract. 14 minus 12 is 2. Bring down a 4. 3 goes into 24 perfectly. It goes exactly 8 times. 8 times 3 is 24. We have no remainder. So 144 divided by 3 is equal to 48. So all season he has kicked 48 field goals. Field goals. Now, we still haven't answered the question. How many did he make in each game? And we're assuming it's the same number in each game. So this is a total number across 16 games. To find out the average he makes in each game, we divide this by 16. So let's take 48 total field goals divided by 16 games. Divided by 16 games is going to be, well, 48 divided by 16 is 3. This is equal to 3 field goals per
Game.
And we're done. How many field goals
Yeah,
did he
got him.
make in each game? He scored 3.
It's gonna be a lot. Practice, quiz, and unit test. I don't want to make a mistake. There's gonna be no mistake. A candy factory makes 4 pieces of candy each for 7 days. Total pieces of candy. For a baking competition, 7 people each made 9 desserts. Which expression can we use to find the total number of desserts made for the baking competition? It's 7 times 9. Which problem can we solve with 2 times 3? Tyler walks 2 blocks north and 3 blocks west. That's addition. Why do I have 4? Joshua has 3 cards in each bunch. Just 2 bunches. So yeah. A summer camp has 9 canoes. Each canoe holds 3 campers. It's no number of campers. Wait, what the? No. A summer camp has 9 canoes. Each canoe holds 3 campers. So 9 times is a total number of campers. Vincent put 4 marigolds in one vase. He filled 6 vases with same number of marigolds, which means find 4 times 6. Which problem can we solve with 9 times 5? No. Okay, this one. There are 9 chefs. Each chef made 5 meals. Taylor made 8 ruby bracelets. She used 6 rubies to make each bracelet. Taylor made 8 ruby bracelets. She used 6 rubies. It's the number of rubies. Okay, cool. No mistake. Next. Okay. I don't want to make a mistake. Jenna's dogs used 9 chews. Chew toys last year. The animal shelter used 2,277 chew toys. How many times as many chew toys did the animal shelter use? What the fuck? Fuck's this question? Jenna's dogs used 9 chew toys last year. The animal shelter used 2,277 chew toys. Oh shit. This is division, isn't it? I need something that would result me to 9 times something to give me 227. Gosh, I don't want to make mistake, but I'm pretty sure this one. Nisa is going to plant 485 trees this year. If Nisa plants 5 orchards of trees, how many trees will be in each orchard? Oh. Okay, so gosh, let's see, 485 divided by 5. Okay, let's try. Yeah. 485 divided by 5. 9. 45, 35, 7. Gregor Mendel is examining P's to try and understand how grades are passed from parents to offspring. Today, Gregor has 2 to 8 P's to examine. The pods have 6 P's per pod. What is this? Today, Gregor has 228 pieces to examine. The pods have 6 pieces per pod. How many pods of piece are there? Oh, so 228 divided by 6. 228 divided by 6. Oh shit. Okay, let's see. 228 divided by 6. It's gonna be 3. 18. 48. Varian rides a horse. Gelbin rides a rocket-powered robo-ostrich. That's sick. Kelvin ostrich run for 8 to 8 meters, which is 2 times faster, as fast as Varian's horse. How far did Varian horse run? I'm gonna divide it. 2, 4, 1, 4. Okay. A seal has 1,500 nerves per whisker. That is 10 times as many as a rat has. How many nerves per whisker does that have? 150. Yeah. Legolas shoots 3 arrows at once from his bow. How many times can I shoot this before it needs more arrows? Okay, 177 divided by 3. We have 5, 15, 7, okay, 59 times. Kira unravels a shirt that gets blue thread. From each centimeter of the skirt, Kira gets 231 centimeter thread. She unravels 7 centimeters of the shirt. What the hell is this? Kira unravels a shirt to get blue thread. From each centimeter of the shirt, Kira gets 231 centimeter of thread. She unravels 7 centimeters of the shirt, so she gets 7 times 231. God, I wanna fuck this up. Thanks. Skills proficient. So good. Give me all that CSS effects. Thank you. Erin had 55 stuffed bears. She took out her favorite 7 bears and then equally divided the other bears among her 3 sisters. Erin's younger sister Sue already had 15 stuffed bears. How many stuffed bears does Sue have now? Holy crap, this is pretty cool. Okay. So if Erin had 55, she took out her favorite 7, then she would have 48. Then divided by 3, we have 16. If Sue's already, she's gonna have 31 in total. After collecting eggs from his chickens, they'll put the eggs into cartons to sell. Dale fills 15 cartons and has 7 eggs. Each carton holds 12 eggs. How many eggs did Dale collect? Okay, so 15 cartons times 12. 10, 2, 3, 5, 1, 8, 1 plus 12. It's gonna be 192. Oh shit, I don't know, mistake, but no way. Each carton is 12 eggs, right? 10. 2, 3, 5, 1, 8. Oh shit, the leftover was 7. Oh my god, 187. The drama group has 90 minutes to practice two scenes. They want to practice the pirate scene 4 times. And time each time takes 13 minutes. The mermaid scene takes 7 minutes. So the pirate scene is 13 minutes, and if you're gonna do that 4 times, you got 62. So 19 minus 62 is gonna be if this is 92, then it's gonna be 30, so it's gonna be 28. I'll go 4 times. What? 4 times 7 is 28. What? Did I not understand this? So to practice two scenes, they want to practice the pirates in 4 times, and each time takes 13 minutes. It's 12, right? So, oh shit, it's 52. So weird. Wow, gosh. That's going to 38. No, I mean, 38. Yeah, 38. Peter scored 15 goals during his second soccer season as a forward. He scored 6 fewer goals during his first season. The whole team as a whole scored 4 times many goals Peter. How many goals did the team score during seasons? Wow. Okay. So Peter scored 15 goals during his second soccer season as a forward. Saving. He scored 6 fewer goals. Okay, so he got 9, the first one. Oh, someone's knocking. Came back. The team as a whole scored 4 times as many as goals as Peter during 2 seasons. Wait, what? So for the first one, Peter scored 15. There's the first and second one. 4 times as many goals as Peter during the 2 seasons. That's confusing. Am I supposed to add this both and then multiply it by 4? 4896. Abbott is planning a birthday party for his granddad. Okay, so he bought a cake for $18. We also want to buy some balloons, which are $4 each. Abbott has $35 to spend altogether. How much money will Abbott have left after he buys the cake and as many balloons as possible? Okay, so we're gonna deduct 35 minus 18. into, it's gonna be 7, 17. It goes into 4 goes into that 4 times, so we have a 1 left over. Squirrel family collected 170 nuts to store for the winter. They spread the nuts out evenly among their 6 favorite spots. Okay, so it's 1 step. It's divided by 6. The squirrel ate the last few nuts that didn't divide evenly. Sadly, a crow stole half the nuts from one of the spots. How many nuts did the crow steal? Okay. Sadly, a crow stole half the nuts. The squirrel ate the last few nuts that didn't divide evenly, so the remainder we don't need it. So it's definitely gonna have a remainder. So 2, we have 12, 5, 52, and then can't be 9. It's gonna be 8 to give us 48. And yeah, I don't need to know the remainder. So we have 28 for each one, and then 14, right? For half the crow stall. An ice cream shop is testing some new flavors. Okay. They invent 25 new flavors for customers to try and throw out the third in these popular flavors. The shop makes 80 cartons of each of the remaining flavors. It takes 2 cartons to get 1 liter of ice cream. How much total ice cream is in the cartons? Okay, let's break this down again. So we have 25 new flavors. We're gonna throw the 13 out, but this doesn't seem relevant at all. The shop makes 80 cartons of each of the remaining flavors. Wait, what? Has I already done the throwing, or is it just making a statement that when the unpopularity thing happens, the shop makes 80 cartons of each of the remaining flavors? Oh, it's remaining flavors, so it's gonna be 12 times 80. It takes 2 carrots, 2 carts, 2 cartons to get 1 liter of ice cream. The shop makes 80 cartons of each of the remaining flavors. To get 1 liter. So let's just first multiply this. So 0, 16. Oh, so we have 960 cartons. It takes 2 cartons to get 1 liter. Divided by 2, right? Oh. If we divide this by 2, you have 4, 8, 1, 16, and 480. Oh shit. Good. The art club raised 248 through fundraisers. They spent to set up an art show. There is another art show. The art club raised 248 through fundraisers. They spent, okay, so 248 minus 206. We have 42 left. There is another at the art show. What the fuck? Is this even multiplication or subtract? Division. How much money did the art club have after the show? What? The art club raised 248 through fundraisers. They spent to set up an art show. They raised another 316 at the art show. How much money did the art club have after the show? Is this a trick question? So weird, man. Okay, so we have the quiz, even though we don't need to do the quiz. See? We're still gonna do it. No, 6 problems only, okay. 7907 divided by 24. Get 3 of that, so it's gonna be 12. 72, right? So after that, we're gonna get 7. Then bring that down. You have 2. You have 48. It'll be 12. Then we're gonna have 127. And I think it should go into 127 no, not 4 times, 5 times. So 24 times 5. So 20, 120, 120, remainder 7. Now we're gonna double check this. I don't want to make another mistake. 7907 divided by 24. Yep, so times 3. We have 12, 6, 72. It's gonna be 7, 70, 2, 48. And with 12, 7, 4. Yeah, why did I do 120 here, right? Right? Not 4, it said 5. Okay, so 3 to 5 with 20. 5, 1, didn't remember when 7. 3 to 5 under 7. Why did I say 12? Holy crap. It's 22, mate. Doesn't even make sense. It's 18, 216. God damn it. Ah. A group of 4 friends is playing cards. The deck has 70 cards. To start the game, the dealer makes a pile of 15 cards in the center. Then she deals the remaining cards one at a time to each player until all cards are gone. What is the greatest number of cards any player will have after all the cards are dealt? So that's gonna be 55. Divided by 4. Wow, that's pretty cool. Wait, what? No. There's nothing that goes into that. I have a remainder, but okay. Uh, the remainder 3. Minus 10 is 60, minus 5 is 55. Then she deals the remaining cards one at a time to each player until all the cards are gone. It's 14, isn't it? Because it goes, the remainders are still given. Oh my god, it's pretty tricky and pretty clever. 160 divided by 30. Oh my gosh. If we do times 5, 1 times 5 is 5 and 15. I'm real turning. At a park, 2 people can ride in each roller coaster car. The coaster has 4 cars. The for for no shit. Some Oh no. I'm losing shit, mate. Things level down. Why is this 3-digit? What the fuck? Oh my god, why 6? If I multiply this, that's more than that. Holy shit, I'm an idiot. 68 times 11. Let's try 11. So 8, 8, 8, 16, 68. We have 8, 14, 7, 48. So it's 11. 48. We have 9 remainder. 623 times 11. 3, 2, 6, 3, 2, 6, 3, 5, 8, 6. So maybe I could do one more. 6, 2, 3 times 12. We have 6, 4, 12. 3, 2, 6, 6, 7, 4, 7. 7, 4. No, not 12. And our remainder would be 7, 7, 0, 0 minus 7, 4, 7, 6, 10, 9, 6. Yep. 4, 2, 2, 4. The 540 times 11. 0, 4, 5, 0, 4, 5, 0, 4, 9. 5, 9. Nope, it's 11. 6, 1, 60 minus 5, 9. 40, we have 0, 2, 11, 220. Okay. Okay, hopefully everything's good. Only need mastery stuff. Okay, we can try again. A farmer had 88 melons growing in her garden. So the farmer had 88 melons growing. In June, the farmer had picked 14 melons. Okay, so let's do 88. Minus 14, we have 74 left. In July, a thunderstorm knocked a branch from a tree and crushed half the melons that remained in the garden. So half of 7 to 4. To 14. In June and July combined. What the fuck? The farmer had 88 melons growing in her garden. In June, the farmer had picked 14 melons. Oh, she picked 14 melons. 14. In July 8, so we have 37 plus 14. 51. Holy shit. I don't want to get this wrong. I'm quite sure it's 51. A class sold tickets to their school play. Each of the 23 students in the class sold tickets. A class sold tickets to their school play. Each of the 22 students in the class sold 4 tickets. The cost of each ticket was 7. How much money did the class earn by selling tickets to the play? Each of the 23 students in class sold 4 times 4 tickets. uh, 12, 8, 9, and then 9 times 7, 14, 64. How much money did the class earn besides? Jordan's mom bought 7 packs of juice boxes for the team to drink after practice. Each pack had 8 boxes of juice. So we have uh, 56. 56 juices, right? 56. After the team drank as much as they wanted, there were 29 boxes of juice. What? Boxes? 7 packs of juice boxes. Oh, okay. There are 29 boxes of juice remaining. The team only opened each pack after they drank all the boxes from the pack before. What the fuck does this mean? Each pack had 8 boxes. After the team drank as much as they wanted, there were 29 boxes of juice remaining. So 50, 16 minus 29 and the 16 for what is this? This is 8. Oh shit. No, 8, it's 17. So we have 27 got drank, right? The team only opened each pack after they drank all the boxes from the pack before. How many packs of juice did the team open? Holy shit. Okay. 27 got drank. So let's divide. Oh shit, this is crazy. The team only opened pack after drinks. So when they got 29. Oh shit, it's so hard, man. There were 29 boxes of juice remaining. So if each pack had 28, then let's see how many goes into it. So they opened four boxes, right? Because uh yeah, they opened 4. It's 32. Because 3 is not enough, that's just 24. How many packs of did How many packs of juice did the team open? They opened 4 packs. Peter scored 15 goals during his second soccer season as a forward. Wait, I've done this before. So 9, 21 times 4. We have 84 goals. Right? Oh my god, I don't know. How the fuck did I fuck this up? Peter scored 15 goals during his second soccer season as a forward. He scored 6 pure goals during his first season. Oh, it's 24. It's 96, dude. Nothing leveled down. Let's try again. Dude, I'm not even in the quiz. Shit. Oh my god, I'm gonna be 4 hours in. $96, right? $27 times 7. It's 9, right? Minus 10 is 80. No. 78 and 74. Then I've already solved this earlier. So 74 divided by 2 would be 3, 6, 1, 4, 7. Nine times 9 is 81. Oh shit. 9 to 81. Why did I write 8? What the fuck? Hmm. Oh shit, not the multi-digit division again. No, I'm not. Not ready, man. Something came down. Nine four four. Shit. Plus 18 is 16. 497. Oh shit, we're wrong. Where did we get this? Remember 18. Get this. So 57, 16 times 3, 9, 3. 57, fuck. 17. It's gonna be 8, 18. It's gonna be 16. Oh shit. 8 plus 96 says 97. Shit. Okay. Let's rewrite the whole thing again. 16 times 7. So I think I did 9 before. No, I did not. 2, 4. Shit, it's large. So 5, 30, 3, 8, 5, 80, 14, 197. One four nine. So we have 16 times 9. Let's try 9. We have the 4, 5, 9, 14. Whoa, whoa. I'm so confused. It should be 5. I guess it would be 3. And 16 times 3. 12, 18, 3, 48. So 57 7 minus 48. You have 17, you have 4. 17 minus 8 is 9. So I remember 9. So 5, 9, 3, remainder 9. Just to confirm. Do 5, 9, 3 times 16. 18. 455. 35. We have 3, 9, 5. We have 8, 8, 4, 9, 4, 8, 8, 9, 4, 8, 8 plus 9 is 9, 4, 9, 7. Fucking shit. Thirty-seven, 3, 2, 6, 5. 37 times 10 times 9, which would give us 50, 63, 27, 33. 63, 6, 27, 33, 333, too much. 37 times 8, 6, 5, 24, 296, 8, 296. It's gonna be 16. This one's gonna be 11. So we have 8, 9, 11, 2. Bring down that guy. 285, and how much? 28. Maybe I can deduct another number. I think 7 is gonna be good. 9, 4, 7, 21. 4, 21, 25. 15, 7, 6, 26. So we have 87, remember 26. So 37 times 87, 9. 4, 25, 6, 5, 24, 29, 9, 11, 1, 10, 12, 3, 1, 2, 8 plus 26. It's gonna be 3, 3, 3, 2, 5, 3, 3, 3. Oh shit, what am I doing? 3, 2, 3, 45. Oh shit, you got the wrong answer. What the heck? Our remainder is 26. Oh my god, this is hard. Where did I go wrong? 9. Oh my gosh. Let's do it again. Three, 2, 6, 5. Let's do 8. 8 times 37, 56. 29 nandito. Oh shit. I mean, it shouldn't be there, right? Eight times 37, 56. Yep. 5, 24, 29. Oh shit. I wrote 6, but I thought it was 8. Okay. I see now, I see now. 205. So 37 times 6. 2, 4. No, just start 37 times 5, 5, 3, 15, 1, 8, 5. Yeah, that's just 5. We have 185 minus 10. So we have just obviously just 20 left over. So then what? This is even smaller number. The heck? Anyway, 37 times 85, which would give us 35, 3, 18, 6, 5, 24, 29, 5, 4, 10, 10, 11, 3, 1, 4, 5 plus 20. No, this is not enough. Gosh, this is hard. Is this even correct? Three, two, six, five. Okay, so our answer is 8, 8 remainder 9. Um, I guess it goes into it one time. 12. Okay, maybe. Oh shit, of course not. If it's 4, 9, 5, 2, then I definitely can afford times 10. Or 11 maybe. 4, 3, 3 times 11. 4, 3, 3. 4, 3, 3. 0, 3, 6, 3, 6, 7, 4. Yep. Import 11. How the fuck am I supposed to write 11 there? Oh my god, this is so weird. Suddenly it became so hard. 2982 divided by 4. Oh shit, it's because you can do 2, right? Okay, so 9, then we have 11 minus 3 is gonna be 8, 1, 8, 9. Oh crap, my balls are itching. Where was I? Okay, so 1, 8 now. Did I not draw already? I think I dropped through already. Yeah. So we have remainder 189. So let's try 9282 times, no, 433 times 21. Two nine eight two. Okay. So we have 29, 21, then 189. This goes twice only. 29181454 1591. So we have 7, just 5, right? 4 and 6, 5, 1, 147. Okay. So remainder 147. So if we do 229 times 12, you have 18, 4, 5, 4, 9, 2, 2, 8, 4, 7, 2 plus 1, 147, plus 15, 9, 8, 2, 8, 2, 8, 9, 5. Okay. So we have 12 and a remainder of 1, 4, 7. God damn it. Now we're back to the quiz. There are 5 chocolate bars. Each bar is split into 8 pieces. God, I don't want to make a mistake anymore. There are 5 chocolate bars. Each bar is split into 8 pieces. Abit is planning. Oh shit, I've done this before. 1. 116. 16 times. Let's say 7, 2, 4, 11. So 16 times 6, 6, 3, 9. One mistake, okay? I'm gonna rewrite. 6, 3, 96. Oh shit, it's 96, right? 96 and 8. Sure, it's 8. 96 plus 10. No way. I wrote 96 instead of 6. Zane is putting the strings on 5 harps. Each harp has 48 strings. How many strings does Zane need for all 5 harps? 48 times 3 is 4. 2, 8 times 6, 48, 50. 11, 1, 17, 63 times 48, gonna be 24, 2, 48, 50, 43, 12, 4, 16, okay, 25, 4, 2, 3, 17, it's gonna be 11, 3, 4, 30, 41, okay, 48, number 17, 1, 1. Basic multi-digit division. I can afford 13 here, right? Yo, what am I doing? Ay, ako'y nababaliw na. Nababaliw na. Thirty-two times, let's say 7. 14. Okay, so it's 32 times 6. That is so weird. Why is the gap so big? 14. 7. 21, 22. That's right. 14, 21, 20, 22. Okay, it's only 7. It's 2 to 4, right? Yeah. 2 to 4 plus 10 is 2, 11. 9, 27 to 9, 11. 9, 6. Gonna fall for this shit again. Comes 5 to 60. I think the 7 is 14. 7, 8, 4. What the fuck am I thinking? 6, 12. Oh shit, I just had 28, 16, 96, so 12, 7, 14, 74, 74. Oh, 74 plus 12 is still fucking 86. What the fuck? 12 times 8, 16. 96. 12 times 7 is 14. 1, 7, 4, 7. The difference is 6. Just to make sure, this is the last one. 7, 14, 7, 8, remainder 6. A squirrel family collected 172 nuts to store for the winter. They spread the nuts out evenly among their 6 favorite spots. Let's give this again. Try. 6, 2, 12, 5, 52. And then let's say 8, because it was 9 is 54 and 8 is 48. 12, we have 4. Okay. 4, so 28. Pamela bought 2 packages of peppers. There was 1 pepper in each package. Pamela bought 2 packages of peppers. There was 1 pepper in each package. What the heck? 2 times 1. That's so weird. Is this a trick question? The frick? Ah, fucking hate long division. 93 93 times, let's say, I think, let's try 5. 15. 45, 46, yeah. Size again. It's gonna be 15. 5, 9 times 5 is 45, so 46. 14. You have 9, 7, 1. It dies. And bring down 2. Let's say 52. 93 is 6. And 18. And 12. And this 2 dies. And we have 6. R6. Let's try this out. If we do 93 times 52, then we have 6 and 18, then we have 15 here, 15, 45 and 46, we have 6, 13 and 7, 8, 4, 8, 3, 6, 4, 8, 3, 6 plus 6 is equals to 4, 8, 4, 2. 4, 8, 4, 2. Yeah, okay. And 52. And we have remainder 6. Okay. Divided by 4 times 8. Okay, so it's 4 times 10, 42. Then we have remainder 5. That's true, right? 42. 7. Okay, so 21. Sorry, multiplied by 5. With 5 and 10, 105. We got 5. And then plus 10 will be 15. 3, 13. Yep, let's try it again. 25. 21 times 5 is 5 plus 10. It's 13. We have 8, 1, 1, 1, 2. Kina is cooking fish for a group of travelers. Kina has 7 to 8 huge fish, and each fish can feed 3 travelers. How many travelers can Kina feed? Okay, so it's 7, 8 divided by 3. Oh, different results. Okay. What? Please don't be. Oh my god. Not again. Why am I so hasty? 2, 6, 1, 8. It's 26. 18. And each fish. Oh, each fish can feed 3 travelers. One level down. What level down? Division word problems. A cat has 24 whiskers by its nose. A manatee has 25 as many whiskers. How many whiskers does a manatee have? Man, getting so tired. 20, 10, 12, 2, 8, 4, 5, 6. Skylar has 4 times as many books as Karen. If Skylar has 164, how many books does Karen have? 164 divided by 4. Leia is heading up 417 toy cars. Each car needs 3 batteries to drive. How many batteries does it need? 21, 2, 3, 5, and Jen has 131 dog biscuits. She wants to give them as gifts to each of her 4 poodles. Jenna has 131 dog biscuits. She wants to give them as gifts to each of her 4 poodles. Okay, it's 131 divided by 4. Uh, 2, 8, 32 remainder 3. Ron and Hermione are lifting feathers into the air with magic. Hermione can lift a feather tube that is 5 times higher as Ron can lift a feather. How high can Ron lift a feather with magic? Okay, so 3, 5, 2, 5 is for Hermione. And Ron is just 7, 35, 0, 2, 0, 0, 5, 5, 7, 0, 5 times 5, 525, 2, 3, 5, 2, 5, 3, 5, 2, 5. How high can Ron? 705. Leslie tunes musical instrument. Leslie tunes a guitar with 6 strings today. She tuned a piano with 37 times as many strings. How many strings did the piano have? What? Leslie tunes musical instruments. A guitar with 6 strings today. Then she tuned a piano with 37 times as many strings. So that's 37 times 6. 37, 6, 2, 4, 18, 22, 222. Lily is using dark powers to crystals raise an army of zombies. Each crystal can raise 9 zombies. 6174 divided by 9. We have 6, 54, 6, 7, 7, gonna have 8, so 7, 2, 54, 6, 6, 8, 6 times 9, 4, no, not 1, times 8, 72, 77, 54, 54, 61, 6174. She's gonna need 686 crystals. Lily is using dark power crystal to raise an army of zombies. Each crystal can raise 9 zombies. How many crystals does she need to raise 6174 zombies? 686 crystals. Okay, let's do the quiz. Even though I don't need to do the quiz. Aris is making 14 jars of honey peanut butter. He wants 45 milliliters of honey in each jar. So 14 times 45. Aris is making 14 jars of honey. He wants to use 45 liters of honey in each jar. How much honey? Okay, 20, 5, 7, 16, 1, 5, mm, uh, 630. Brian has 8 slices of pizza. He eats 2 pieces. How many? Wait, what? There are 2 puppies in each cage. An ice cream shop is testing some new flavors. Okay. There are 13 flavors. So we have 12 times 80. I think this was 460. Answer this one or something. Anyway, let's just do it. So 12, 16, 9, 2, 1, 6. What am I doing? What the fuck? I'm out of my mind again. So we have 12 new flavors times 80. So we have 0 and 0. We have 16. 9, 8. Oh, so we have 960. And we want to divide that by 2. So we're gonna have it 4, 8. It's gonna be 1, 6. And then we're gonna have 8, 16, 60, 0, 0 for 80. Please don't be wrong. I know you're for 80. Let's do the major 1. Oh, here again. I hate this. 6, 1, 1, 6. 5, 5, 2, 8. Okay, so I'm gonna say 2. 2 times 2 is 4. 16. 4. It's gonna be 11. It's gonna be 10. So this one's gonna be 7, 4, 6, 1, 2, 8, 2, 4, 3, 17, 9, 1. Okay, that's my remainder. So 2, 8, 2 times 21 is 2, 8, 2, 4, 16, 2, 5. Add all that shit up. Left there. 12, 1. 6, 7, 8, 9, and 5. Then if we add 194 to that, 4, 6, 11, 10, 10, 6, 1, 6, 6. So good. We have, it's gonna be 21. Then we have remainder 1, 9, 4. Oh, okay. Not division. I hate division. Okay, 16 times. Let's try. Let's try. It's not gonna be 8. Let's try 6. 6, 3, 6, 96. 16 times 7. I feel like I've answered this before. 4, 7, 11. 7. I mean, if I had 16 to this, I have 1, 2, 8 anyway. So I think it's just 8. I mean, there's 0. Before I enter, you have 16 times 8. Eight, 4, 1, 2, 8. So yeah, there we go. Cool. Then we're gonna do the unit test now. "31 mother freaking questions." Time is it, dude? Okay, I'm doing for 4 hours now. Ah, shit. Gotta get some water. Sex, let me grab some water. Alright, 2 expressions. It's gonna be 400 plus 80 plus 2 times 3. And 400 times 80 times 2. Gosh. Use partial products to multiply 4955 times 2. 2 times 4 thousands. 2 times 9 hundreds. 50 tens. That's be 9,910. Now I don't want to fuck the shit up, so 9,800, 900, 10, 9, 9 and 10. Is this 5 tens up? 2 times 5 tens. Fiona tried to evaluate an expression step by step. Find Fiona's mistake. 8 divided by 2, 40 divided by 2, plus 6 divided by 2, correct? Okay, it's definitely wrong step 2. Oh man. The following error model shows 57 times 2 broken into parts. Find the area of each part. So A is 100 and B is 14. 114. Yep. Which 2 expressions are equivalent to 5 times 87? Okay, it's 5 times 80 plus 7 and 85's. Is this right? 85's plus 75's, yeah it is. It's 100. 6 times 100 is 16. Choose number line by 6 plus 1 times 9. What is this? Zero to 9? What the fuck is this? I mean, 1 times 9 is 9. It's the only one that gives him 9 answer. Nine three divided by 76 be 8 13. You have 7 8 9. Speaking of 2 of 2's, we're going 12. 12 14 15 7 7 2 3 76 maybe 3 of these. 18, 21, 25. Yep. 2, 5, 8 as shown there. We have 13 and 6. So it's gonna be 1, 1 and 5. Damn, turning stupid. So let's say 76 times 123 times 76. 18, 13, 7, 0. 7 times 3 is 21. 2, 14, 15, 16, 8. It's gonna be 8, 4, 3, 9 plus 15. That's gonna be yeah, 3, 6, 3, 9, 9, 9, 3, 6. Oh shit, it's 1993. 5 times 8 is 40. Oh yeah, this is quite correct. Just made a stupid mistake here. 5 times 8 is 40. Oh shit, if that's 40 then red fucked up. Oh, we're not multiplying though, we're adding. So 3, 5, 6. Oh crap. Let's try again. 9, 3, 6, 3, 7, 6, 1, 76. We have 13. It's gonna 7 and 8, 7, 1, 7, 6. We have 2 over there. So this one's gonna be 12. 12, 1, 2, 14, 15, 152. 4, 243. It's gonna be 3 as well. 3 and 1, that's gonna be 18. 21, 21, 22. This one's gonna cancel out. This one's gonna turn 3. It's gonna be 13. 13 minus 1, 5, and then 1, 15. Okay, so maybe I made a mistake in the multiplication part. So let's say 76, 123. So 76 18, 13, 6, 7. This one's gonna be 21, 1. 21, 2. 21 to 14, 15, 16, 7, 8, yeah, 8, 4. Oh shit, what the fuck? What the fuck? 8, 4, 13, 9, 3, 4, 8. This is not enough. If I add 15, it's still not enough. Why is it 6, 3 here? Oh no. 9393, man. 76, 13, 7, 2, we have 12, 13, 17, 15, 179, we have 7, 2, 3, 3, we have 18, 21, 22, 7, 13, 6, 3, 5, 45, 9, 76, 1, 2, 3, 18, 12, 13, 6, 7, 0, 1, 2, 7, 4, 6. Oh, where was I? 21, 2, 7, 14, 15, 16, 7, 8, 8, 4, 13, 94, 8 plus 45, then 3, 9, 9, 3. Whew. Yeah. Use the following image to help find the total number of rabbits. 9 fours 36. The garden has 3 rows with 8 cars in each row. How can we find out how many cars there are in all? It's 3 times 8. Oh, crap, okay. 20 divided by, let's do, if I do times 8, it's gonna be 160. If I do 9, it's gonna be 180. 9. And then we have 6 remainder. And just to be sure, 29, I don't want to repeat everything. 0, 180. Yep. 9, 180, we have 6. Ugh. Years play of the era of Iraq to help me solve a division equation. What division equation did Jerry solve? Okay, so 700. Oh crap. Okay. 746 divided by 6. 720, 724, 726. 1, 6, 1, 14, 2, 12, 1. 26, and then we have 6. Yep, 6. 6. 4, 24, and the remainder 2. 1, 2, 4 times. Oh shit. Which expression we use to calculate the number of flowers? 3 times 7. Yep. Just one answer. Which problem can we solve with 42 divided by 7? Julie had 7 bags of jelly beans. There are 42 jelly beans. No, it's Leslie ran for 42 minutes total in 1 week. If sharing the same number of minutes each day, how many minutes is less in 1 day? Use the image below to help fill in the blanks. There are 2 groups of 9 monkeys. 1, 2, 3, 4, 5. There are 18 monkeys in all. Which expressions are equivalent of 5 threes? 5 times 3. Choose to answer. No. I really can't afford to make a mistake now. Ben uses 9 lemons to make a pitcher of lemonade. There are 6 pitchers of lemonade. Ben uses 9 lemons to make a pitcher of lemonade. There are 6 pitchers of lemonade. 9. No, total number of pitchers. 9 lemons to make a pitcher of lemonade. There are 6 pitchers of lemonade. Total number of lemons used. Which image could represent 20 divided by 4? No, it's this one. Okay. Nine. Remainder 1. Because 9 times 8 is 72. And we have 1. After collecting eggs from his chickens, Dale puts the eggs into cartons to sell. Oh fuck, this is what I got wrong with before. After collecting eggs from his chickens, Dale put the eggs into the cartons to sell. So 15 times 12. Dale puts the eggs into cartons to sell. Dale fills 15 cartons. Okay. What can say? After collecting eggs from his chickens, Dale puts the eggs into cartons to sell. Dale fills 15 cartons and has 7 eggs left over. Each carton holds 12 eggs. Okay, so it's definitely 15 times 12. Which is 10. 2, 3, 5. 1. Then the leftover 7, 1 is 7. Please be correct. Thank you. Multiplying. How many dots are there? 30 dots. No, I don't want to make a mistake, please. Fill in the blanks, solve 50 times 4. Wait, what is this? Times 5 times 4? Okay. This definitely 200. So 10 times 5, 10 is 20. I don't know what, any bonehead mistakes. 6 more questions. We got this. The following area model shows 29 times 20 times 97 broken into parts. The image is not drawn to scale. So 1200 for letter A. 2 times 9 is 18 in the 2 zeros. Okay. B. We have 2 times 7 is 140. And for C, we have 9 times 90. It's 810. And for D, we have 9 times 7. That's going to be 63. Then that's also going to be 180 plus 810 plus 140 plus 63. 10, 3, 4, 10, 11, 16, 18, 1, 2, 1, no, not 2, 1, 2, 8, 1, 2. Be sure, let's do 97 times 29. 3, 6, 81, 87, 14, 1, 9, 18, 19, 3, 11, 18, 1, 2, 183. That's 183. Yeah, I'm pretty confident with my answer, I guess. Double check. 1, 8, B, 7, 20, 140, C, 9, 810, D, 763. Okay. Split up the area of a rectangle to help him solve the division equation. He splits a rectangle into parts that are easy to divide by 6 and a remainder. Complete the equation. So, 420 divided by 6 will be 700. B, 120 divided by 6 will be 200. Wait, what? Uh, Sure. Yeah, right. 6 times 20 is 120. Yep, that's correct. For C, we have 24 divided by 6. This can be 4. Plus 4 times 6 is 24. And we have a remainder. So what we're gonna add is 724. It's gonna be 724 with 4 remainder. If we configure that, if we solve it via long division, 6 mirror 7 and 42, 14, 2, 12, you have 2 again, then 8, it's gonna be 7, no, it's 7. 6 times 4, yep, because 5 is 3 is 30, so it's gonna be 4 again, 74. It's gonna be 24, we have 4 remainder. Then 724 and 4 remainder. 700, B, 20, 4 units. Thank you. Brew blew 91 bubbles. Ken blew 7 bubbles. How many times as bubbles did Bry blow? 7. Oh. 13. Bry blew 91 bubbles. Ken blew 7 bubbles. How many times as many bubbles did Bry blow? Did as 13 is that many times? Okay. 4, 1, 7 times 27. See 9. 4, 7, 11, 28, 29. 14, 2, 3, 8. We have 9, 5, 12, and 11. 11259 is the answer. 11259. To be sure, you can do it again. 417 times 27. 7 times 7 is 49. 7 is 4, 11, 28, 29. 0 here. 2, we have 14. 2, 2 times 1 is 1. 3, 4, 8, then add all that. We have 9, 5, 12, 1, 11. 11, 2, 5, 9. 11, 2, 5, 9. Cool, we have 3 more. There are 18 apples. We want to divide them equally into 3 baskets. How many apples will be in each baskets? We have 6. 12. This is really getting me paranoid. I use partial products to multiply 73 times 42. So, 7, 4, 7 times 3 ones, that's 6. And then we're gonna add everything. It's gonna be 2,800 plus 140 plus 120 plus 6. That's gonna total 6. 6, 10, 3,066. And to be sure, we're gonna multiply if we are correct. It's gonna be 6. We have 14. Yep, 0 here. And then 4. Let's see. 12, 4, 28, 29. We have 6, 6, 10, 1, 3, 0, 6, 6. Alright. 3066 square. For the last time, I don't want to pop up. I'm getting paranoid. Okay. 7 times 3 ones and 2 times 7 tens. Correct? 40 times 3 ones. Okay. 140, 120, 6 and 200 and 2,800. We have 6, 6, 10. 066. Okay. Last question. Let's go. Lena starts to use the standard algorithm to solve 39 times x. Her work is shown below. What number should Lena replace m with? So this is the carry. So we have 9 times 4, which is 36. It's gonna be 3. I'm not gonna fuck this up. I know it's 36. I believe in myself. You know what? I'm gonna solve the whole thing anyway to make it more complete. Times 4. So we have 6, 36, 4, 12, and then 15. 156. You know what? I'm gonna make this super complete because this is the final problem for this one. This is crazy. 9, 18, 6, 3, 15, 3. There we go. Yeah, mastered over there. Whew. Never give up, never surrender. So good. Holy crap. Took me almost 5 hours. So good, man. Made so much mistakes, but yeah, still perfected them. Never give up, never surrender. Sales notifications. Yeah, okay. Let's go to can. I guess that's it. We have 35% for arithmetic. So from 22% to 35. Yes? Yep, it is indeed. Let's see from missions if that increased the mastery. Oh shit, the world of math, we're at 10%. Yo, this is pretty sick. Pretty sick, mate. Damn, it's already 2 a.m. in the morning. So I guess I'm gonna rest and I'm gonna continue again tomorrow. So, yeah, thanks. Bye bye.